And then we should see it over on the YouTube page for the Shy Hat, which is my channel over here. That should be showing up in just a few seconds. So as usual, I'd like to say that we do have a YouTube page over here, and we have some YouTube shorts, which also feature my favorite birds. These are some Stellar J chicks. They are the best. But anyways, let's get that live stream link. Whoops, this is not it. Okay, so this should be the link right here. Let me copy that link. And anybody who's interested in taking a look, it is over at this link right over here. Okay, so with all that done, let's start our class. So this is HackerFrogs After School Python Programming Basics Part 8. So it's been the time has kind of flew by. It's only been about about 3 weeks or so that we've been learning about Python programming basics, but it feels like it's been not very long at all. So this workshop is the 8th and final class for Intro to Python Programming, and during our last workshop we learned about a few programming concepts through Python, including the following. We learned about dictionaries. Dictionaries in Python are similar to other container objects such as lists, except that the data stored in dictionaries are pairs of keys and values as opposed to individual items. Dictionaries are useful for recording different key-value pairs that all pertain to one subject, or one common value across a number of subjects. So we could do a whole dictionary about John's vital statistics, such as height, weight, age, and gender, anything else that we want. And this is how we could keep track of data like this. So in this workshop, we're going to be covering two topics. The first thing we're going to talk about is modules and packages in Python, and the second thing we're going to talk about is how to write Python scripts to help us solve CTF challenges. So let's start. So let's talk about modules. So in Python, modules, they're pieces of software that serve a specific purpose. Modules typically contain a number of functions, classes, variables, and/or methods which can be imported into a Python namespace to make use of extended functionality. So you might be asking, what is a Python namespace? So anytime you have a Python environment, let's close this ad. So this is the Python namespace. So you've got a bunch of variables and different data objects in this namespace, and they all have different names, and that's what we refer to as Python namespaces. Particle to Do on Twitch says, good evening to you, Particle to Do. We're just starting a lesson on Python programming over here. Maybe not anything that, well, I'm not too sure how well you know Python, but you're welcome to sit in if you like. All right, so that's Python namespaces. Namespaces are a collection of defined symbolic names and their corresponding values. Every Python program exists within a namespace, and importing modules into a namespace adds objects from the module into the current namespace. Particle to Do says, I'm a noob. I'm sure you're selling yourself short. I'm sure you know more than you're letting on. Okay, so let's talk about these modules. So how can modules enhance our Python programs? As an example, the Python random module contains a few different methods for generating random numbers or rearranging pre-existing data into random configurations. So we could try to recreate the code over here. We've got a number list. We can import the random module. Let's go into the online Python space and do just that. So let's get hands-on. So we're going to import the random module. So import is a keyword, and whatever follows after is going to be the module that's going to be imported in. So after we import the random module, we're going to be able to use all of the functions and methods inside the random module. And as we said before, the random module gives us a few different ways to rearrange and create random numbers. So we could do a number list, and that's going to be 1, 2, 3, 4, 5, 6, 7. Okay. And then after that, we're going to do random underscore list. That's going to be number. I think what we're looking for is random.shuffle, right? So random.shuffle is going to take the numbers in a list and shuffle them all over the place. So let's do that. So that's random list equals random.shuffle, and inside the parentheses we have to provide the object that's going to be shuffled around, which is this over here. So when we do print random list over here, then what we're going to do is we're going to print out this list over here, but the order of the objects in the list are going to be randomized. So let's run this. It says none. It says none. Did I do this incorrectly? Let me take a look again. Print numList, random.shuffle, numList, print numList. Oh, okay. We have to run this on it first, and then we're going to, okay. So what we need to do is we need to print the number list again. So here we can just run this function on the number list, and then we print the number list. So we print the number list, and we get this. So the numbers have been shuffled around. Okay, cool. User PK, are you having some sort of problem? Please let us know if you're having a problem, and we'll try to help you solve your problem, okay? To anybody in the class, if you're having any problems, please let us know, and we'll try to solve your problems, okay? As long as they pertain to this class, not any old problem. Okay, so in order to use module functionality, the module must be imported into the namespace. This can be done in one of two ways, either by importing the whole module into the namespace, as shown above, or we can specify which methods or functions to import from a specific module, like the examples shown here. So in this example here, in the previous example, we imported the entire random module, but in this example, we're going to only import one function from the random module here. So in Python, we do from random import shuffle. So we do the same thing. The syntax for running the shuffle function in this case is slightly different because we didn't have to use the random name when we were using the shuffle here. Let me demonstrate. So over here, we had to do random.shuffle in order to run this function over here, but we can also do it a different way. So from random import shuffle, and in this case, we can do just shuffle the number list because the entire random module wasn't imported, but only the shuffle function was. So we can just run the shuffle function. We can just call the function over here with numList directly, and then we can get the same result over here. Born Again 2 has followed on Twitch. Thank you very much, Born Again 2. Welcome to the HackerFrogs. Okay, so let's move on. Okay, note that when we import specific functions from a module, we can access those functions without specifying the module name, like we did in the first example where we had to use random.shuffle. And in this case, we just do shuffle because we didn't import the entire random module. So today what we're going to do is we're going to learn about two different Python modules that are going to help us solve CTF challenges. So the first Python module we're going to look at is the Python socket module. So the Python socket module can be used to connect to and interact with networking ports on remote servers. So when we're dealing with CTF challenges, we often have to contact specific remote servers, computers on the internet, on different networking ports, and that's what the Python socket module is going to help us do. So the other module that we're going to be learning about today is the Python requests module. The Python requests module can be used to perform web requests and obtain data from websites. So there's the difference between contacting remote servers on specific networking ports and contacting them on web ports is that web ports are well, maybe you don't need to know about this, but web ports are usually on a very specific networking port, like port 80 or port 443, and you can access them with a web browser. But services on other ports, like maybe there's a service on port 600 or port 6666, and you can't normally use web browsers to access those services. So that's what we need the socket module here for. If these things don't quite make sense, they'll make more sense when we finish the lesson today, I think. Okay. So we're going to learn about the socket module, and we're going to talk about the request module. So let's learn how to use the socket module to solve some CTF challenges. So what we're going to do is we're going to take a look at the GitHub page over here, and you can access it from this link. So first of all, what we're going to do is we're going to log into picoctf because we're going to use these Python scripts to solve some CTF challenges on picoctf. If you're not logged into picoctf, you can do so from this link over here. Let me just grab the link. So just go ahead and log into your picoctf account. Once you're logged in, please access the practice page. So when you're logged into picoctf, you'll see this practice link over here, this practice button rather on the menu. Just press on that. And we can also open up our web shell. So everybody, if you're logged into picoctf, please type in the chat, "I'm on Pico," smiley face. Okay, user D is on Pico, great to see. If you're already on the website, you can go ahead and open up your web shell. I'll demonstrate how to open up the web shell right now. So, to open up the web shell, after you've navigated to the practice page, just scroll down a little bit, and then the web shell button on the website is going to be on your right-hand side. So it's this button right here. So you can go ahead and click on that, and that's going to start up the web shell session. So if for some reason it doesn't load up, you can try either clicking on this button over here that says reload the web shell terminal, or you can close out the web shell and then you can click on the button again. But after you've logged into the web shell, you can make the web shell big inside of your terminal. You can make the web shell a bigger terminal, rather, by clicking on this button right here. And this is the button labeled Pop Out Web Shell Terminal. Just click on that. and that's going to start up the web shell terminal in a separate browser tab. If for some reason it seems like the web shell terminal is not being responsive, you can try reloading the page. So just go over and click on reload. Okay, so you might have to do this a couple of times in order to get in, but eventually you should get in, and then if you're able to log into your web shell and you see a prompt over here that says your username dash picoctf at web shell, then please type in the chat web shell up, smiley face. Okay, we've got some web shells coming up. Great to see. All right. Okay, great. Okay, so let's go over to the GitHub page, and once again, the GitHub page you can access from this link over here. Okay, so the first challenge we're going to do is this what's a netcat challenge, but for the first thing we're going to do, so let's access the what's a netcat challenge. So I'm going to copy the link and provide it to everybody in chat. You can also click on the link directly from the GitHub page itself if you like. So picoctf, paste in the challenge link, and we see here, this is the what's a netcat challenge. So the challenge description over here, it says using netcat NC is going to be pretty important. Can you connect to this server over here at this port to get the flag? Okay, so normally what you do in this challenge is you use the netcat command to connect to the server, but we're going to be tackling this challenge in a slightly different way because we're going to be using Python in order to interact with the server and get the flag. So now that we know we need to connect to this server over here on this port, let's take a look at the script we're going to be using to solve the challenge. So over at the GitHub page, there's a link over here to the socketconnect.py script that I've written. So you can access it from here. Okay, so let's take a look at what this script does before we start using it, okay? So the first thing that happens in the script is that we import the socket, the socket module. So you remember that the socket module is, I wonder if I can get some more space. Okay, I'm going to make this nice and big so that you can read it better. So the first thing that happens inside the script is that it imports the socket module, and the socket module is used to communicate with specific networking ports on remote servers. And then on line 6, 7, and 8, we're going to define some variables. So the variables are going to be server, and the server variable is going to be equal to some input. We're going to ask the user to input the server domain. So this is the computer that we're going to be contacting on the internet. And the next variable is the port variable. So the port variable is going to be an integer, and we're also going to be inputting, we're going to be getting user input, enter the networking port number. So we're going to supply to the program the domain that we're going to contact, as well as the networking port number we're going to be contacting. And we're also going to be creating an output file. So when we run this script, we're going to be saving the response from the server into a file called socket_response.txt. So these are the initial variables, next, on line 10, we're going to create a function. So this function is called connect to server. There are three things we have to supply to the connect to server function, which is the server, the port, and the output file, which are defined up here. So this is where the socket, starting on line 12, this is where the socket module objects actually come into play. So we're going to create a socket object, and that's going to be called this variable. So the variable we're going to create is called client socket. It's going to be a socket object, so it's socket.socket, and then we define some parameters here, socket.afinet and socket.sockstream. So these are just some things we need to supply when we're creating our socket object so that it can communicate properly. So the next thing we're going to do on line 14 is we're going to do a try except block. So we didn't quite have enough time to cover this, but when we're running some code, we can run it inside a try except block, which essentially means that we're going to try to do something, but if there's some sort of error that happens, then it's going to try to handle those errors a little bit more delicately than just simply crashing the program. So we see here that what we're trying to do is we're going to try to connect to the server by doing client socket, which we created up here, dot connect. So this is a method inside the socket module, and it's going to connect to a server on a port, and then it's going to print connected to server on port, this port. Particle to do says it's a loop. Is the try except, are you saying that the try except function block is a loop or something else? But let's see. So the next thing we're going to do is we're going to create a file, and this is how Python creates a file. So with open output file in write and binary, I think this is the B, as file, it's going to create the file, and then inside the file it's going to do some things. So while true, so this is basically an infinite loop here, it's going to start collecting some data. So the data is going to be received from the client socket here. It's going to receive, I think these are bytes. These are 1024 bytes. And it's going to keep on receiving the data until no more data is received. So that's this portion here. If not data is going to break, and then the while loop is going to break. It's also going to write the data each time it receives data, and then it's going to print that data using the UTF-8 encoding over here. So data.decode. And then finally it's going to print data successfully recorded in output file. So the other part of the try except block is this one over here, which is going to try to handle errors and exceptions gracefully. Accept exception as E, print an error occurred, and then the name of the error. So finally what we do is we're going to close out the socket that's connected to the server, and then, okay, I need to get out of here. So the thing is that we've defined this function up here on line 10, but nothing actually happens in the code. So we've created the function, but the function actually doesn't do anything unless we call the function. And the very last line of the code is going to call the function. So connect to server, the function we created, server port output file. So let's try running this script. So what we need to do is we need to go over to this button over here. So at the top of the GitHub page, there's going to be this bar code blame, and beside the raw button over here, there's this button called copy raw file. So go ahead and click on that, and then go over to your web shell. The web shell probably disconnected,
that's fine. Just hit enter to reconnect to your session. Okay, so from there, we should probably work inside of directory here, and let's just make a directory called, let's just call this one netcat. And then we're going to enter the directory. So make the directories and then move into the directory. And now we're going to create our file. So this file is going to be called socket_connect.py. So we're creating a Python file here with the nano program. So nano space socket_connect.py, hit enter. And now we're inside of the nano text editor. So we copied the code. What we need to do now is we need to right click and select paste. And that's going to paste the code in. So this is all the code that we were reviewing on the GitHub page. We don't need to do anything after we paste in the code. All we need to do is save the file. Does anybody remember what keyboard shortcut we used to save the file inside of Nano? So if you don't remember, there are a bunch of shortcuts over here that tell you what these things do. So Particle to do has it correct. In Twitch, he says it's Control X. So it says here Control X to exit. So just hold down the Control key and hit the X button. It's going to ask you if you want to save the modified buffer. Press Y for yes. And then hit enter to confirm the file name. Okay. So after that, you should have socket connect.py. And if you read the file, cat socket_connect.py, you should see all the code over here. So if you were able to read the file after writing it, after creating it with Nano, please type in the chat, I read the Python file, smiley face. Let's see. In Twitch, Particles do ask, the name of the script is important to run it. You could name this file anything you like, but just if you just want to copy what I'm doing, you can call it socket_connect.py. The important thing is that it's not the name of the file that's super important, it's the contents of the file that's important. But just for the sake of the exercise, please please name it the same thing that everybody else is using, okay? Okay, so now that we have this file written to our web shell over here, what we can do is we can run the file. So we can do python space socket_connect.py. So python space socket_connect.py, hit enter, and then it's going to ask you the question here, enter server domain. So we can get the server domain from the challenge page. So we're trying to solve this challenge over here. What's a netcat? And if you don't have this page, I'll just provide it to everybody again if you need the link one more time. Okay. So on the description page, this is the server domain that we need. So go ahead and copy that. And make sure you don't grab any spaces. So right-click copy, then go back to your web shell. So it says enter server domain, right-click, select paste, and then hit enter. Then it's going to ask you enter networking port number. We're going to go over to the challenge again and grab the port number. So this is the port number here, 25103. Copy that. Then go back to the web shell, right click paste, and then hit enter. So the script is actually giving us what the server sent us, and it also saves it to the file socketresponse.txt. So it says connected to this server on this port, you're on your way to becoming the netcat master. And then it gives us our flag over here. So the last line that is output over here says data successfully recorded in socketresponse.txt. Okay, so we can finish this challenge, but actually we can also read this file as well. So we can just read socketresponse.txt and it'll give us what the server sent us over here. So to solve the challenge, all we need to do is copy the flag value over here, and then go over to the challenge description, go down to the flag submission field here, paste in the flag, and click on Submit Flag. And it looks like I'm going to get timed out by the server. So once again, if you're having any problems with any steps that we're doing during the class, please let us know, and we'll try to help you out and get you on track. But if you manage to finish that challenge, please type in the chat, "I scripted the challenge away." Smiley face. Okay, great to see, great to see. Okay, so we're going to try doing a couple more challenges. The next challenge we're going to try to do is over here. Okay. So the next challenge we're going to do is we're going to be doing using a different library to solve the next challenge, which is the Inspect HTML challenge. So LargeOx is now a HackerFrog. Thank you very much for following on Twitch, LargeOx. So I'm going to copy this link and I'll provide it to everybody in chat. Okay, so after that, go over to your PicoCTF challenge page and paste in the link. Okay, so this is actually a web app hacking challenge. It's called Inspect HTML. The description says, "Can you get the flag? Additional details will be available after launching your challenge instance." So this is a challenge where we need to launch an instance, basically a cloud computer that has the challenge on it. But we're not going to do that yet. What we're going to do is we're going to take a look at the script we're going to be using to solve the challenge first. So let's go over to this, not this page, this page. And we're going to be using this script over here, which is called the request Python script. It's called web page fetch. So let me grab the script link and provide it to everybody here. Okay. So when you click on the link, it should lead you to this page over here. And this is another script that we're going to be using to solve the challenge. Let me make it bigger. It says here that this script uses the Python request module to make a web request to a specific web page and writes its content to a file on the host machine. So basically it grabs the content of the web page and then it saves it to a file. So what happens in the script? So on line 5 over here, it imports the Python request library. And the request library is used to interact with web pages. On line 7, there's a URL variable which is defined as the user input. Input the desired URL. So it's going to ask the user for the URL it wants to access. And then this output file is going to be defined as well. So the variable output file is going to be input as well. What name do you want to give the output file? So we want to give it, usually the landing page of any website is going to be called something like index.html. But sometimes it's not. The next thing that we do is we make a function. So the function in this case is going to be called fetch webpage. So fetch webpage has 2 parameters. It has the URL and the output file. We do another try except block. And this script is actually much simpler than the previous script. So let's take a look at what we're doing in here. We're going to try. We're going to create a response variable. It's going to be equal to the request module get method. So this is just going to get the web page, and it's going to get the URL that we specify. There's going to be a raise for status method over here, which is going to be run if the request is not successful. And the next thing we do is we write the content of the response into an output file with this method that we saw in the last script. So with open output file in write mode and encoding UTF-8 as file. So basically this is opening up a new file for writing, but inside, so whenever we're talking about this file here, we just call it file. So we just do file.write response.text, and so response over here is this request get. We're going to write the text of the response into the file. Then we're going to print web page content successfully recorded in this name, output file. So except for if there's some sort of error, request.exceptions.requestException as E, an error occurred, and then it's going to print out the error. The last thing that happens in the script is it's going to call this function, fetch webpage, with this URL, with this output file. So this is the script we're going to use to solve the challenge. What we need to do is go up to the top. This button right over here is going to copy the raw file. Go ahead and click that. And then go over to the web shell. The web shell, it might have disconnected. If it disconnected, just press enter to reconnect. We're going to back out. And because we're finished, so just do cd by itself. You should see the netcat directory in here. We're finished with this directory now. We can delete it. So just rm space r netcat, hit enter, and that'll delete the directory. So we're going to make a new directory now, and this is going to be, what's this challenge called? The challenge is called inspect HTML. Okay, so let's make a directory. Let's call it inspect HTML, and then enter that directory. Oreo Bytes is here in Twitch. Hello. I see your Vohio, your foxtail emojis, and your light sticks. Thank you very much. Okay, so now that we're inside the directory here, we can nano space webpage underscore fetch .py. So just name it webpage underscore fetch .py. Nano space webpage underscore fetch .py. Hit enter. And then we've we're now in our Nano text editor. So right click, select paste, and that's going to paste in all the code that we copied from the other page. Okay, so we're going to save the file. So that's going to be Control X. Save modified buffer, press Y for yes. Press enter to confirm the name. And we should see that webpage_fetch is in our directory now. So let's read that file. And we should see the code that we just wrote to the file. If you can read the file and it's there in your directory, please type in the chat, "The script is ready to go." Smiley face. As usual, if you're having any troubles with any of the steps that we've been doing in today's session, please let us know, because we don't want anybody to get left behind. So I'll give everybody just a few seconds. I need to take a sip of water. It's getting mighty thirsty. Just a second. Okay. So we should see webpage_fetch.py in our directory now. All we need to do is run it. So we're just going to use the Python command to run the script. It's going to be webpage_fetch.py. So Python space webpage_fetch.py, hit enter. And then it's going to ask us to input the desired URL. Okay. So we go over to the PicoCTF challenge, and we're going to launch our instance. So just click on the Launch Instance button here, and that's going to start up the cloud machine that has the website. So you might get an error when you press the button. In that case, you need to wait for about 10 seconds or so, and then PicoCTF, the website, will show you an error. Then you're going to re-click on that button. But once you see that the button turns red over here, then you're fine. Okay. So we only have 14 minutes to solve this challenge. Once this instance has started, you should see that there's this link over here. It says go to this website and see what you can discover. So what we need to do is we need to copy this link. So just highlight over the link, right click, select copy link, and then go back over to our web shell. So in the web shell, it still says input the desired URL, right click, paste, and then hit enter. It's going to ask us what name do you want to give the output file. So what name are you going to save the file under? We're going to call this index.html, and then hit enter. Okay, then it says web page content successfully recorded in index.html. We should see after we run the script that there is an index.html file in here. So all we need to do is read the file. Does anybody remember what command we used to read this file? It is the cat command. Right, okay. So we just do cat index.html, hit enter, and we get this. So this is the content of HTML files. So what we actually see when we in the web browser is this part over here. Well, we also see this part. But there's a lot of stuff inside of these HTML files that we don't see. So all of this code stuff over here, we don't see any of this when we open it up on our web browser. But if we download the web source code file directly, this is what we would see. But inside of here, there's also the flag inside of this HTML comment, this HTTP comment rather. So this is how we solve the challenge. Just highlight the flag over here, copy it, then go over to the challenge page. In the flag submission field, paste in the flag and click on Submit Flag. And you should be done. So sometimes you might have to, there might be an error. So if there's an error, you just have to wait 10 seconds and try again. Okay, so everybody, if you managed to finish the challenge, please type in the chat, "We scripted the thing." Smiley face. Okay, so I don't know if we have enough time for one more challenge. Let me take a look at what other challenges we have on. So over here. Okay, we've got, let's see. We've got the scavenger hunt link as well. OreoBite says, working on Hack the Box. No worries, no worries. Thank you very much for being in the chat. Always good to see you here, OreoBite. Okay, so let's try the scavenger hunt challenge over here. I hope we're able to finish it within the 8 minutes that we have left. We'll see if we can get it done or not. So everybody, this is the link for the challenge. Okay, so it says there's some interesting information hidden around this site over here. Can you find it? All right, so we have a static website this time, and that's fine. That just makes it faster for us to finish. So the first thing we want to do for scavenger hunt over here is we want to prepare the environment. So to prepare the environment, we're going to go back to our web shell, and we already have our web page fetch script over here. So what we're going to do is we're just going to delete the index.html file. So rm index.html. So we could shuffle around this this web page fetch file and create a new directory, but we're just going to not do that because we want to save a little bit of time. So we already have the file over here. It's all ready to go. So we can run this script again. So we're just going to do python space webpagefetch.py, enter, input the desired URL. So we just need to go over to the challenge page and copy the link for the web page. So copy that link and then go over to the web shell. In the web shell, paste in the link, hit enter. What name do you want to give the output file? Let's just call it index.html again. Web page content is successfully recorded in index.html. So let's read the file. Okay, so we see in here that this is in HTTP HTML page rather. It just says some boring HTML. It says here, how do you like my website? I use these to make the site. HTML, CSS, JS, JavaScript. And it says, here's the first part of the flag. So there's 3 parts to the flag that we need to collect in this challenge here. So what we need to do is we need to copy the first part of the flag. So remember that all the picoctf flags start with the word picoctf. So just copy until the letter T here, copy it, then go over to the challenge page, and then in the flag submission field, paste in the first part of the flag. So the first part of the flag, we're just going to keep it here for safekeeping. We're going to add on to this afterwards. And then once we have the whole flag, we're going to submit the flag. So go over back to your web shell. So you'll notice over here that there are a couple of links inside this code here. So can anybody tell me what the link sources are for the links inside this HTML file? If you know, type it in chat. But if not, I'll highlight it in just a few moments. On Twitch, Weedworm says, hello Weedworm, how are you? Nice to see you here. We're just doing the end of our Python class. We're going to be moving on to some free hacking in just a little bit, but you're welcome to stick around and learn about Python or about how to hack stuff. The question was, what is the name of the links in this file? So there are 2 links in this file. What are the names of the links? Okay, so there is this link right here in the header. This wasn't the link I was looking for. I was actually looking for this link right here, which is called mycss.css, and myjs.js over here. So what we're going to do is we're going to download these as well. So these are 2 other files inside of this website, and we can download these as well. So what we're going to do is we're going to run the web page fetch file again. It's going to ask us for the desired URL. I think we still have it copied, so we can paste it. Oh no, we do not. Okay, so we're going to go back and we're going to copy this link, then go back to the web shell, paste in the link. Oh no, let me do that again. Copy the link, go to the web shell, paste in the link, and then on the end of this, we're going to put in my css.css. So because that was the name of one of the links, just hit enter. And then what do you want to give the output file? We're going to give it my css.css, hit enter, and web page content successfully recorded in my css.css. Okay, so we're going to read the file. And this is the CSS file that is also on the website. So this is like a regular CSS file. It makes the website nice and pretty. But at the end here, it says CSS makes the page look nice. And yes, it also has part of the flag. Here's part 2. So part 2 here is this. So everything from the H until the 0 here, copy it. Then go over to the challenge page and paste in the second part of the flag. Okay, so don't submit the flag. We're going to copy this this link again, then go back, and we're going to run the Python web page fetch again, and we're going to insert the website, but we're going to add something else to the URL. So it's going to be myjs.js, which was the other link that we found in the index.html file. What name do you want to give the output file? myjs.js. Okay, and then we're going to read that file, myjs.js. Okay, so this is a JavaScript file, which can run a bunch of different code and run it on the website. but it also says, how can I keep Google from indexing my website? Oh geez, I forgot that this was so long. This is kind of a long challenge. Okay, let me speed run this challenge so that we can finish it quickly. Okay, so what we can do to keep Google from indexing the website is to have a file called robots.txt on it. So what we're going to do is we're going to run web page fetch again. We're going to paste in the URL, but at the end over here, we're going to type in robots.txt. What name do you want to give the file? It's going to be robots.txt. And then we can read robots.txt. Okay. It says, so this is, the robots.txt file is a file on web pages we can use to prevent search engines from looking at them. But we also have a part of the flag. So we can just copy this, then go over to the description page, paste in that part of the flag, recopy this over here, then go over to our web shell, and we're going to, oh, wait. So it says, I think this is an Apache server. Can you access the next flag? So the next flag is going to be at the, man, I wasn't expecting this. Okay, so it's the same URL, except we're going to access the .htaccess file. So this is a file that is on the Apache web server, which that gives it security permissions. It's going to be called a .htaccess. And if we read that file, it says, I love making websites on my Mac. I can store a lot of information there. So we also have a part of the flag, so we can just copy that, then go over and paste that part of the flag. Okay, so just to make this short, the last part of the flag we can access by copying this thing again. And there's a file that's specific to Macs that have web pages, which is called .ds_store. .ds_store. So DS is capitalized, S is capitalized, there's an underscore here. Hit enter. This is .ds_store. And if we read that file, it says, congrats, you completed the scavenger hunt, and there's the last part of the flag. So just copy this, and then go over to the page, paste in the last part of the flag, and click on Submit Flag. Okay, it says, hooray, you solved this challenge again. Okay. All right, so right before we finish today's class, I'd like to I'd like to say thank you very much to everybody who participated in the HackerFrogs Python basics classes. There are a lot of this is just a little taste of what coding in Python is like, and I'd like to point everybody towards a resource for learning more about Python. So we've got our HackerFrogs Reddit page over here, and there are a bunch of different threads on here that talk about different topics. I'm looking for this one. No, I'm not. Wait. We're looking for just a second. I think it's Python language resources, online and mostly free. Okay, please take a look at this link over here. And this thread over here on the HackerFrogs Reddit has a bunch of different links for different places you can get more education on Python. What I'd like to highlight is this course over here called Skills for All, and Skills for All Python Essentials 1. Let's just open this up. So Skills for All is a website where you can learn about different tech topics. So this one is Python Essentials 1. And let me... you saw something. You saw something, I'm sure. User D says, did she see Batman doing something? Well, I think you saw something. All right, so this is the course that I recommend if you want to spend more time learning about Python. And this is a 30-hour course, so you can go through it at your own pace. It's for beginners, but this is a very good course. I've looked through it myself, and it's endorsed by Cisco, which is the really big networking company. So it's really good, and it's also free. So I highly recommend you go ahead and try out this course if you want to learn more about Python. Okay, so Weedworm says, what are you working on? Go back to the CTF. We're going to be working on more CTF stuff in just a little bit, but right now what I need to do is I need to close out the class with the Zoom students right now. So we'll be back in a couple of minutes, and then we're going to start some more hacking exercises. But we'll be back in a couple of minutes. I just need to finish the class with the Zoom students, and then we'll come back to hacking in just a couple of minutes. Okay? Okay, everybody, we're back. Okay, so the Python class is over, and what we're going to be doing is we're going to be shifting gear, and we're going to be doing a little bit of hacking exercises. We're going to be doing a few hacking exercises before we do our next class. So the next HackerFrogs class is going to be on web app hacking, and that's going to be in an hour or so. But until then, oh, Cybershell. Cybershell followed a couple of minutes ago. Thank you very much for following Cybershell. And you ask, is there a Discord channel? So there's no Discord channel for HackerFrogs right now, but we do have a Reddit subreddit. So if you wanted to chat about anything beginner hacker related, you can do so at the following link. Okay. Just a second. Okay. Let's so for this section, before we do our next class, I'm going to start playing some music, and this is going to be from the Mass Effect 2 soundtrack, and it's really great music for doing programming and hacking. So please enjoy. I just need to hook up the sound to the stream. Let's see. Particle to do. I says I hope it's TMCA for Twitch. Well, oh, that should be a bit loud. Let me turn down the volume. But yeah, particle to do. It's okay for Twitch. It's less. Yeah, well, I hope it doesn't get flagged. Yeah, I think I've been okay with the Mass Effect 2 soundtrack on recordings before, but it shouldn't be too bad. Anyways, all right. So what we're gonna do is we're gonna do a little hacking demonstration right now, and the demonstration is gonna be for a machine from the VulNyx website. So first of all, let me grab the file that I'm going to be using for that. So VulNyx, low difficulty. So we're going to be doing a demonstration of how to compromise this system over here. It's called the Doctor machine. But before we do that, I need to start up the virtual machine associated with the with this challenge. So this is VulNyx and vulnyx.com. You can access it from this link over here. And VulNyx is a website where you can download virtual machines and put them on your own network and then do hacking against them. So we're going to be going way back into the past, and we're going to be doing the Doctor machine, and I'm going to be showing you how to compromise the machine step by step. And it's essentially going to be a bit of a speed run. Hopefully hopefully we can get this done in about 15 or 20 minutes. But and I'm going to try to illustrate exactly what vulnerabilities are present on the machine while I'm doing so. So let me start up the machine. Particle to do says it's an easy box. Yeah, it's an easy box. Eternal blue? No, it's not eternal blue, but it is an easy box. You'll see. So we've got the box running over here. It is running at IP address 10.0.2.48. So that's the IP address we're going to be hacking against. Okay, so so first of all, I need to create a little environment to work within. So what I'm going to do is I'm going to create 3 tabs inside of my Kali Linux machine. Tickle My Totem Daisy says hello. Hello, Tickle My Totem Daisy. How are you doing? Okay, so let's move into the temporary directory. So the reason I work inside of the temporary directory when I'm solving these CTF boxes is that sometimes I need to download files or tools in order to solve these exercises, and I want them to be deleted after I'm finished with them. So that's why I move into the temporary directory. Anyways, let's kick off this challenge. So everybody here can say hi YouTube, because eventually this video is going to go up on YouTube. So this is the doctor machine. It's machine number 7 on the VulNyx website. So let's start our scans. So the first thing we want to do is we want to run nmap on the website, the server rather. Nmap is going to tell us what ports are open on the machine. So we run it with common scripts and versioning information against all ports in very verbose mode with these different arguments here. We also run it in with 4 threads, meaning that it's fast but not too fast. So after we run this, we're going to see that there are 2 ports open on the system. There's port 22. There's port 22, which is run in SSH, OpenSSH with version 7.9, and there is also a web server on the system, which is running on port 80. It's the HTTP service with the Apache web server software with version 2.4.38. So if you have any questions while I'm working through this box, please let us know and I'll try to answer your questions as best I can. So since there's only one port that we can investigate, what we're going to do is we're going to first run a Nikto scan against that particular service. So Nikto is a web app vulnerability scanner, and web app vulnerability scanners are going to be able to pick up some low-hanging fruit vulnerabilities for web pages that it finds. So this is a bit, the music is a bit loud. I'm going to turn it down. Okay, that's a little better. Okay, so another thing we can do after we find that there's a website on this server here is that we can manually navigate to the website. So over here, we're going to 10.02.48, and we're going to investigate the web server. So the web server over here is hosting a website. So this one's called DocMed, I guess. And we can take a look at the different links. We can hover over the links and take a look at what they lead to. So there's an index, there's a department page, there's a blog page, there's a pages page, there's a doctors page. So if you can see the where the page leads to, it actually leads to something that looks a bit suspicious. So we're going to click on this link. So if you see over here, there's something suspicious in this link over here that points to a certain web app vulnerability. Can you identify it? Okay, Particle to Do has it locked in. He identifies the vulnerability that could be here. It's called LFI. So LFI, let's introduce a couple of concepts before we move on, okay? So where are we? Here, okay. So the first thing we're going to talk about is URL parameters. URL parameters are variables attached to the end of URLs. They can be identified by the question mark directly after the web page or directory name, followed by the parameter key name, then the equal sign, then the value. So we've got our startup parameters here, our key, the equal sign, the value. Okay. If there are multiple parameters included in the same URL, they're separated by the ampersand symbol. So here we've got an ampersand symbol separating 2 URL parameters right over here. So there are a few different reasons why web pages use URL parameters. The most common one is for search queries. So if you go to google.com and you run a search, then whatever is on the next page is going to read something like this: search, then question mark, and then q equals whatever it is that you searched for over here. However, another common and potentially dangerous use of URL parameters is to instruct the web server on which web page to display. So we've got over here the URL that we just talked about is doctor-item.php, but it includes the URL parameter include equals doctors.html. So the URL parameter is telling the web server what file to load into the web browser. So this is potentially dangerous. The use of URL parameters which reference other files on the web server could potentially be exploited in an attack called local file inclusion, or for short, LFI. Local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities can lead to sensitive data exposure and can also be used as the first step in a chain of exploits. The inclusion of file names in URL parameters is a typical method through which a potential LFI vulnerability is identified. So let's talk about how we're going to exploit this particular website. But first, a little lesson on local file inclusion file system structure. So what we do when we include an LFI payload to the web server is we use a bunch of these .. instructions, and each one of these instructions is going to indicate an elevation of one level in the file system, traveling from the web app's working directory up to the top level directory, which in Linux is known as the / directory. So normally we would, inside of a web application, we would start in this directory here, var html www. Each time we do the .. we move up one level in the file directory up to the top. From there, we can try to access the file that we want on the file system. Let me demonstrate. So over at the vulnerable website, over here, so we see that include equals doctors.html. So this is the file that is being loaded. What we can do is, after the equal sign, we can include a bunch of .. to move up in the file system. So after we've gone up far enough so that we get up to the top level in the file system, we can indicate the file we want to access, which typically on Linux web servers is the etc password file. If we can read this, and this is usually a globally readable file, we can see all the users on the file system. So let's do that, and we're able to see all the files on the file system. If we want to look at this in a slightly prettier way, we could go over to the view page source and look at it in this view instead. So these are all the users on the web server over here. So before we talk a little bit more about this, let's go back to the presentation. So from the top level directory, we can provide a file path to the file that we want to access. A typical test file for local file inclusion on Linux Unix web servers is the etc password file, since it is publicly readable by default and gives info regarding usernames on the web server. So using LFI, we are able to view the etc password file, which includes a user called admin. If the web server is not secured properly, we could view this user's common private files, so the files inside of their home directory. So let me demonstrate here. So here, these are all the users on the web server system, including all of the service accounts that need to be present in order to run these services. But at the bottom here, there's this admin user over here. So this is not a standard user. So you might think that admin is a standard user on web servers, but on Linux servers, the root account is essentially the admin user. But this is a custom username, and we could potentially access private files inside of the admin user's home directory over here. So we know the home directory is /home/admin. But what else we can do is we can go back up to our LFI payload, and we can read. Well, let's take a look at the presentation first. So local file inclusion, we can do private SSH private key capture. So because we know that there is this user on the system and that they have a home directory, we can potentially capture their SSH private key. Cybershell asks, aren't the passwords supposed to be hashed? Is this because the web server was not secured properly, or is it that way because of learning purposes? We can look for the SSH key, says Particle Do. So Cybershell, so the password file doesn't actually have passwords. So if you take a look here, there are no passwords in this file. So in the past, the etc password file had passwords in the file, but afterwards they moved all the passwords over to a new file called the etc shadow file. So the etc password file has this X over here, which is where the passwords used to go. But the X now indicates that the passwords are hashed and in the shadow file. I hope that helps answer your question. So, but we can't access the shadow file because we don't have permissions to access the shadow file. So if we try to access the shadow file, then it's not going to return anything to us. Particle to Do talks about log poisoning. We can also use the LFI vulnerability to do what is called log poisoning, but that's a slightly more involved web hacking technique. We won't be talking about that today. But anyways, so if we access the home admin /.sh.id/RSA file over here, this is the admin user's SSH private key, which is this over here. So because we can access this, we can log in to the web server as the admin user. So not on the website, but directly via the SSH service. So what we would need to do this is copy the contents of the IDRSA file here. Just copy that. Then go over to our terminal inside of Kali Linux. And we would do... Gabriel De Silva just subscribed on YouTube. Thank you very much, Gabriel De Silva. Thank you very much. Okay, so we're going to create an IDRSA file with Nano. So inside the Nano editor, we just paste in the contents of the SSH key, IDRSA, and then save the file. So the IDRSA file has to have specific file permissions in order to run properly. We see that groups can read the file and anybody can read the file over here. We need to change this. So what we're going to do is we're going to use the change mode command, chmod, with 600. 600 means that the file owner can read and write the file, but the extra zeros over here means that everybody else cannot read or write or access the file. So we run this on IDRSA, and then we see that only the file owner can read and write to the file. So these are the correct file permissions. So the next thing we need to do is we can try to log in. We can try to log in to the server as the admin user using SSH with this command. But then it asks us for the passphrase for this key. So SSH keys can be protected by passphrases, and that's basically a password that's only used if we try to log in using this key. So we don't know what this is, so we need to exit out of here, and we need to try to crack this passphrase. So we can try to crack the passphrase with a program called John the Ripper. But in order to, we need to get the hash from this IDRSA key before we can run it with John the Ripper and determine what the passphrase is. So what we can do is we can run a utility called Ismac says there's a lot of out of sheer luck moments in this example machine. Normally we wouldn't be this lucky. Well, Ismac, I agree, and it's not an especially realistic machine because there's a lot of weird security misconfigurations on the box. But this is for education purposes, and I think we should approach the box as though it's an education exercise and not a realistic scenario. But yeah, we can try to crack this IDRSA key passphrase. But first we have to run the SSH2John utility on the key and output that to admin.hash. So afterwards, if we take a look at admin.hash, we see that this is a long hash that we can feed to the John the Ripper program. So we can just run John the Ripper with the word list rocku.txt, which is a list of about 14 million passwords that we can try to compare against the hash over here. So we're going to compare it against this admin.hash, and hopefully John the Ripper is able to get us the passphrase for the SSH key. So very quickly, John the Ripper is able to determine that the passphrase for the IDRSA key is unicorn. So we're going to run that. So we're going to use that as the passphrase. So SSH IDRSA admin at this IP address. It's going to ask us for the passphrase. We were able to crack it using John the Ripper. It is unicorn. And we're now in. Okay, so we've managed to log into the server as the admin user here. And the first thing we want to do is we want to do the sudo l command to see if the user has any specific sudo permissions on the system. And it says command not found. So this is Spanish. It says orden no encontrada. I think that means command not found. But another thing that we can take a look at are the file permissions for specific files. So if we take a look at the file permissions of the etc password file, we see that there's actually very loose permissions for this file. This is not standard, but the password file can be written to, which is really bad news because the etc password file can be used for privilege escalation. So let's talk a little bit more about how we would use the etc password file for privilege escalation. So privilege escalation is how we escalate our privileges after from a regular user to a super user, and this is password write permission abuse. So the system's password file has insecure permissions, allowing any user to modify it. So, oh, I forgot a slide here. So there's supposed to be a slide here talking about how we need to create it. So what we can do is we can create a new user inside the etc password file that has the same user permissions as the root user. So the first step is to create a password using OpenSSL. So we can do OpenSSL password and then the name of the password that we want to use. So we're just going to use the password called password, and it's going to give us a password hash. So this password hash we need to feed it to the etc password file and set this as the password for the new user. So the second step is to add a user to the password file. Note that the zeros in the command over here are going to indicate that the user's UID and GID, so the user ID and the group ID, are both 0, which is the root users. So this new user we're creating in this command is essentially going to be a root user. This is the root user, just under a different name. So let me grab my notes so I can get this command. Okay, so if you're interested, this is the command I'm using. I don't know if that's going to... Yeah, okay. Okay, so this is the command I'm using over here. So this command over here, so the X needs to be replaced with the file, with the password hash that we created with the OpenSSL command. So we're just going to delete that. We're going to copy the file hash, the password hash rather, copy it and paste it in, and then we're going to send this command. What this is going to do is it's going to add a new line to the password file with a new user called the shy hat. The shy hat is going to have a password equal to password, which is hashed as this, but they're essentially going to be a root user because their UID is 0 and their GID is also 0. Okay? So let's write that. So when we switch users to the newly made user and use the whoami command, we are effectively logged in as the root user. So let's do this. Password is password. And our prompt over here says we are root at doctor. If we ask who am I, we are root, okay, and we can finish the exercise. So to finish any of these CTF box exercises, you move into the root directory and you read the root.txt file. So out of respect to the people who run the VulNyx.com website, we're not going to read the root.txt file on live stream because they don't want us to do that. But what we are going to do is we're going to read the root.txt file and redirect that into a file called iReadRoot.txt. So we see that iReadRoot.txt and root.txt, they have the same size, and if we run md5 sum on the root.txt file on the iReadRoot.txt file, they have the same md5 sum, so we essentially read the root flag over here, which means we finished the exercise. Okay, so thank you very much for watching this live demonstration. Once again, if you have any questions about any of the things that we did in the exercise, please let us know. But this is going to be up on YouTube, and because I'm going to be doing a series of these things, talking about the privilege escalation and initial access techniques that I got for each one of these boxes. But we still have a little bit of time, so what we're going to do is we're going to do some hacking against a different system. Let's see. Ismac, once again, I'd like to say thank you very much for your input regarding these CTF boxes. They're not these easy machines usually have some unrealistic stuff on them, but once again, they're pretty they're meant to educate people as to what happens if these unusual security problems are present. Weedworm asks, do you ever do live bug bounty stuff? You do not want to do live bug bounty stuff. Because if you do live bug bounty stuff, then you can get into all sorts of trouble. Because first of all, what you do is you discover vulnerabilities on websites, and anybody who's watching can take advantage of the same vulnerability that you find live on stream and do bad stuff with it. So you definitely do not want to do live bug bounty. But yeah, I mean, it's fine if you don't find anything. It's a very bad thing if you actually do find something, especially if it's a critical vulnerability. But that's my opinion regarding live bug bounty stuff.
Okay, so let's shut down the machine. So this was Doctor in the books. Let's shut it down. Ismaki asks, how do you identify the vulnerabilities the first time? What's your process for messing around and trying stuff? Well, I can demonstrate. Let me grab a system. Well, I can actually use this system, even though I've done this system before. Let me grab a system that I'm currently working on. So this is another VM that I downloaded. It's called Printer, and this. So Ismaki, do you work in tech? It sounds like you work in tech. Are you a cybersecurity professional, or are you somebody who works as a system administrator or something else? So okay, so Printer over here, it's at 10.0.246. Okay, let me start working against this. I'll show you my usual process. So this terminal has frozen because it is not being used. Wait. Tab, tab, tab. Get rid of this. So the usual process I like to do when I'm doing one of these CTF boxes, it's Particle D2 says it's all about methodology and practice. So the first thing I like to do is I like to run an nmap scan. So nmap is going to tell us what open ports are on the system. This is 46. I run it with a number of different arguments and flags to determine what ports are open on the system. Ismaki says, just got the certs, but thought it would be a nice topic to talk about if you wanted to explain. Which certifications are you referring to? Okay, so we have 3 ports. There's port 80, there's port 22, there's port 9999, and this is the unusual port on the system, because this is not a standard port. So when I see port 22, I know that there's usually not too much we can exploit as far as port 22 is concerned. That's SSH. Advertisement. Sorry to hear. Ismaki says, OSCP and did the coursework for CRTO and CRTP. Well, Ismaki, if you just got your OSCP, then you must have done dozens or hundreds of these boxes. So that's so you I'll show you my methodology for doing CTF boxes. If your methodology is different, then let us know how it's different. Ismaki, you've probably either have you been working in IT before, or did you get the OSCP before getting any other type of job experience? I'm interested in knowing. Weedworm says, I have the Sec Plus and OSCP, also did coursework for CRTO. Oh, Weedworm is also an OSCP. Okay. GG for your OSCP. Yeah, for sure. Weedworm, I'll let everybody know that I did the coursework for OSCP. I took the exam, but I didn't get it. But I did get a lot of good experience by running through as many of the lab machines before my access ran out. But yeah, I did OSCP training, but that was before they decided to put all that Active Directory stuff in there. So I was running the OSCP when it still had the buffer overflow machines. But yeah, as soon as I see that there's a printer service running on this port over here, 9999. So you can connect to it.
you can do netcat. It says that this is a Konica Minolta printer admin panel. It's going to ask for a password. I don't know what the password is. So you can look up all sorts of default passwords for these machines, and you might be able to come upon one. The OSCP changes now. Okay, more entries in AD. Yeah. So essentially, if you can't do Active Directory, you can't pass the OSCP exam anymore. Ismaki says, I used to run the Hack the Box Discord server for some years, was interested in seeing how you approach the unknown. Yeah, so the unknown in this case is this unusual service running on 9999. So initially what I did, I spent several hours looking up default passwords for Konica Minolta printers, and none of these worked out. So what I decided to do was I decided to enumerate the rest of the web server. So of course I run my Nikto because I love using obsolete tools. So I'm just kidding when I say that. Some people say that Nikto is an obsolete tool. It's still a useful tool. It can get you low-hanging fruit findings, stuff like shell shock and maybe some other one. I think it might be able to pick up on stuff like Heartbleed, some other really old and obscure web app vulnerabilities as well. It is very old. Yeah, so I also like to run dirb. I like to run dirb because the syntax is very easy and it usually comes back really fast. So for example, I got this API endpoint over here from the dirb list. So I know that there is an API directory. So I'll usually run dirb before I run dirbuster. And I see here that there's an API endpoint, and there's a printer's endpoint inside the API directory here. That would probably take me a lot longer if I were to search for it using GoBuster. So from here, I can actually navigate to the printer's endpoint, API printer's endpoint here. So if I go over here and then I do 10.02.46 API printers. So I get this message over here, search for your printer using the following format, printer id.extension. Printer id.extension. So ID is probably, I don't know, it might be a word or it might be a number. I'm not sure. .extension, I guess that's a file extension or something. So I could start looking for that. But generally, if I find some sort of endpoint like API or printers, I'll probably try to fuzz it with GoBuster with a crap ton of different extensions over here. So I guess we can add some JavaScript, we can add some zip files, maybe we can do XML, we can do JSON stuff, and we can look for any unusual endpoints over here. So the thing about GoBuster is that if you feed it too many file extensions over here, it's going to run super slow. But that's fine as long as you have enough patience for that. So just to heads up to everybody, we're going to be starting our next HackerFrogs lesson in about 10 minutes or so, and that lesson is going to be on web app hacking. So the web app hacking class is actually kind of coincidental because we're also going to be talking about local file inclusion in that class. But yeah, to anybody who's interested, you can go ahead and take a look at the VulNyx challenges over here. VulNyx is a website that's very similar to VulnHub. VulnHub is a very old school website that has vulnerable virtual machines as well. So if we go over to VulnHub. VulnHub has been bought out by Offensive Security, So Offensive Security and VulnHub, they share machines now, I think. Another good website for doing CTF boxes like this is HackMyVM, hackmyvm.eu. And this is, well, this is a slightly more complicated website, but there are a lot of good virtual machines on here as well. So we can log in. Let me grab my password. Okay, so let me get my password for HackMyVM. So hackmyvm.eu, we've got the machines over here. How many do they have? They've got 776 VMs. If we compare that to, well, that's probably not a lot compared to something like Hack the Box. But if we compare it to VulNyx over here, they have 107 VMs. So it's quite a bit. Cybershell says, I found this online Spanish. Dockerlabs.es. I've never seen it. I've never seen this website before. But I guess a box is a box. Well, if you download a box and you hack against it and you learn something, then that's a good thing. That's my opinion. So I guess these are Docker containers that you can download and hack against. This is pretty cool. Thank you very much for the link. I might be doing this on my stream in the future. There's also this link. I guess this is another service. They're in Spanish. Well, I mean, I guess I mean that's fine. We can do a little bit of Google Translate. That's I found that there's actually quite a thriving cybersecurity community that is Spanish speaking, for sure. And also Brazil seems to be a very popular place for learning cybersecurity and hacking stuff. But thank you very much for the link. Okay, so, but Cybershell. Yeah. Do you have any? Are you aiming to get a cybersecurity related job in the future? Something like pen testing, web app pen testing, bug bounty stuff. Weedworm says, heading out for the night. Thanks for the great stream. My LinkedIn if anybody wants to connect. Yeah, for sure. Let me grab that that LinkedIn. I'll send you an invite. I'll send you connection. For sure, no idea what. Well, I mean, you did the... Cybershell says you love InfoSec. Oh, I believe it. Yeah. Let's see. LinkedIn. Okay. All right, Weedworm. Yeah, I'll try to connect to you on LinkedIn, but let's send you out with a Hack the Planet. Okay.
Hack the planet! Hack the planet! Shut up and get in.
Yeah, Cybershell. If you're looking to get into cybersecurity right now, I think if you know how to do AWS or like cloud stuff, that's what they want pen tested the most right now. There's a great series of labs that is all about AWS pen testing. It's right over here. So this teaches you how to do all of the common security tests for AWS. So stuff like S3 buckets and Lambda instances. It's good stuff. No worries, no worries. Yeah, I love sharing. I love sharing. I love teaching. I love learning. This is all stuff that I like to do. Thank you very much for following Weedworm on Twitch. Thanks for the follow. But let's shut down the printer machine over here. We're actually going to be doing a blind. We're going to be doing a blind CTF solving of the first machine. Let's find it first. Over here. So it's number 58. So Cybershell, if you want a fun easy challenge, then you can try to solve this box over here. It's machine number 58 on the site. Just download that and deploy it, and you could probably solve it before I finish my class in about an hour or so. But otherwise, I'm gonna be trying to solve that box after the class is over. That's gonna be in about an hour or so. Okay, so is anybody here for the web app hacking course? If you're here for the web app hacking course, please type in the chat web app hacking, or you can type in HackerFrogs. Let me pause the music for now. We'll play some more music a little later, but let's see. Let me just take a little drink. You talk all the time, you get a little thirsty. Okay, so I need to get ready for my class. I need to get my notes. This is web app hacking, and we are doing session number 3. I had to start closing some of these tabs. So many tabs. I'll keep these ones up. And I need to get my session notes. Web app hacking, session number 3. Okay. Okay, so just to the people in chat, has anybody here taken a look at the over the wire NATAS labs? Because we're going to be covering those labs today. That is over the wire. I think we're going to be doing NATAS level 6. Okay. All right, so let's wait a couple of minutes and then we can start the class. If anybody has any questions or comments that you want to ask before the class begins, go ahead and type them in the chat. We're doing HackerFrogs web app, so let me change out my overlay. Where is it? Here we go. So this is HackerFrogs web number 3. Okay. Okay, so it is 5 o'clock local time. So what we're going to do is we're going to start our HackerFrogs After School Web App Hacking Basics class. This is part 3, session 3 rather, and let's begin. So what we learned in the previous workshop, this is the 3rd intro to web app hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. Is Mackie
Izmaki is now a HackerFrog. Thank you very much for following on Twitch, Izmaki. And yeah, hope to see you here in the future while we're doing some more hacking exercises. I'm sure you've got lots of advice you could give us to help us root those machines. Okay, so we talked about the HTTP refer header. The HTTP refer header, which is misspelled on purpose, contains the value of a complete or partial address of the web page that is making the request. It is often used for analytics or logging. The HTTP refer header is occasionally used by web app developers as a security mechanism, but this is not a good practice as it was never intended to be used in such a way. We also learned about HTTP cookies. So the HTTP cookie header and HTTP cookies are commonly used as a security mechanism that allows users to maintain an authenticated user session on the website. In short, HTTP cookies allow users to log into websites. But since cookie values can be modified by the user, proper care should be taken to ensure that valid cookie values are not predictable or easily guessed. Let's continue where we left off. So we left off at level 6 of the Natus CTF game, and it is at this link right here. Let me grab the link for everybody in chat so that you can use it. Okay. So this text is way too big. Okay. So to anybody who wants to continue on with the course, I would recommend that you go over to tryhackme.com and create an account at the website, because we will be making use of some of the modules on that site in order to do some of the lessons. So it's you don't need to pay for registration over at tryhackme.com. You just need to create a free account over there, and we're probably going to be starting that next week. All right, so we're talking about let's see, Natus level 6. So over here, we've got Natus level 6 at this link right over here. When you arrived on that page, it's going to ask you for a username and password. You can go ahead and use the username Natus6, and you can use this password over here. Just paste that into the chat for everybody. Okay, so when you arrive on the site, you're going to see this pop up over here. The site is asking to sign in. You need to provide a username, and the username is Natus6 without a space. The password is going to be the password that you copied, the password that was provided to you in chat. Let me copy that. Let me paste that. Sign in. Okay. All right, so this is the Natus level 6 landing page over here. So on the landing page, you should see this input secret field over here, and this button over here to submit query. There's also a view source code button over here. Okay, I think this is the right size. So what we can do is we can start playing around with this. So input secret, we can type in test, click on submit query, and it says wrong secret. So what do we do to try to solve this level? So we obviously have to figure out what the correct secret is. So in order to do so, we need to take a look at the source code for this application. So conveniently enough, the source code is right here, and we can put this in a new tab, and then we can take a look at the source code. And the source code is not in the HTTP code and the HTML code. It's this right here. This is the PHP code for this particular web page. So this is an example of something called source code analysis, and let's do a little bit of reading about that. Oh, I guess Hold on. I guess we don't. I guess we don't talk about source code analysis. Okay, that's fine. So source code analysis is studying the source code of a particular app or website in order to better understand its function. So if we go over to this over here, so this is. Does anybody know what kind of language is being used in this code here? And what is the telltale sign that this is the language being used? So if you know, Cybershell says PHP. That's correct. So this is PHP, and you know that this is PHP because only PHP uses these particular code initialization, I guess they might be called, opening and ending brackets. Right. So if you ever see bracket question mark and question mark bracket to open and close out let's see, a snippet of code, then you know this is PHP. So another thing that gives away that this is PHP is this keyword right here, include. So I think only PHP uses the include keyword. So I could be wrong, but we could ask something like ChatGPT about this. So let's open this up real quick. ChatGPT, give us all of the answers in the form of gangster rap. What programming language uses the include keyword? Okay. Oh, so it's also used in C and C++, but it is also used in PHP. So PHP, if you're familiar with Python, so the include keyword in PHP is very similar to the import keyword in Python. It basically lets you load in code from another file. So if we go back here, so the file that's going to be included, the file whose code is going to be included for this code here is in this file path, includes/secret.inc. So what's going on in this in this code snippet? So if array key exists, submit post. So if there's something in the field, we're going to submit it as a post request, and then it's going to do another if condition. So if the secret variable is equal to the post secret variable over here, so this is posted, and post whatever was in the post is a secret in this case. It's going to print access granted. The password for Nana 7 is this. Otherwise, it's going to print wrong secret. So where can we find this variable? Secret. So $secret is the variable that we need to compare against. But where is this defined in the code? So do you see it defined here in the code? If not, where could it be? So if your answer was that this secret variable is not in the code, so it must be in the included code, then you're correct. So this is an endpoint on the website here, includes/secret.inc. So all we need to do is copy that, then go over to the website and provide this as an endpoint, /include/secret.inc, hit enter, and we see, well, there's nothing here. This file is blank, but what you can do is you can take a look at the source code. So just take a look at the source code by either doing right click and then view page source. You can also use the Control U keyboard shortcut. And we see here that inside of this PHP code, and remember the question mark bracket question mark means PHP.
we see that the secret variable is equal to this. So this is what's being compared to when we submit in the field over there. So all we need to do is grab this string, then go back to the original web app. And in the original web app, we're going to paste in this string that we found and click on Submit Query. Okay, so the response is access granted. The password for Nata 7 is this right here. So this is the password we're going to use to access the Nata 7 page. So we're going to copy this. And to anybody who wants to use it, I'm providing it to everybody in chat. Okay, so we can access Natas level 7 by going up to the URL here and modifying the URL. So instead of Nata 6, it now says Nata 7. After you do that, hit enter. And then Nata 7 is going to give you a pop-up over here. So just in case you were wondering, this is an example of what is called basic authorization. This is the earliest version of how logins were performed on websites before the cookie method was perfected. So in this case, you have to provide a username. It's Natas7, and the password is whatever we just captured from over here, and then click on Sign In. Okay. All right, so what I want you to do is I want you to take a look at the links over here. So there's this landing page here. There's these two links. There's one for home and one for about. Can anybody tell me what's unusual about these links? If you know, go ahead and type it in the chat. We can actually take a look at the links in here as well. So it's line 15 and 16. There's something suspicious about the way these links are laid out. Can anybody identify what that is? Okay, so this is the part where actually, wait, there's a hint over here. The password for web user natas8 is in /etc/nataswebpass/natas8. So this is a hint that we're actually going to access the web server files in order to complete the level. So in order to explain what's going on here, let's first talk about URL parameters. So it might sound a little bit like a broken record because we were just talking about this previously, but let's talk about URL parameters. So URL parameters are variables attached to the end of URLs. They can be identified by the question mark directly after the web page or directory name, such as this over here, followed by the parameter key name, then the equal sign, then the value. So this is the key, and this is the value. If there are multiple parameters included in the same URL, they are separated by the ampersand symbol. So we've got our question mark that denotes the start of the URL parameters. Then there's the key, the equal sign, the value. And then if there's more than one, there's the ampersand over here. And then the other key, the equal sign, and the value. So there are a few different reasons why web pages use URL parameters. The most common one is for search queries. So let's demonstrate. So over at google.com, ooh, that's not how you spell Google. Okay, if stay signed out, if you're on google.com over here, and I'm going to search for, let's search for something super simple, like birds. Okay, so if we search for birds, inside of the
URL parameter over here, we're going to see something like this. So I've just typed in the chat, but so you're going to see something like this: google.com/search Q for query equals birds. So this over here is a URL parameter. So Q is the key and birds is the value. So this is how we provide search queries to different endpoints on different websites. Okay, so what else? However, another common and potentially dangerous use of URL parameters is to instruct the web server on which web page to display. So over here, we've got our Natas website, and we've got index.php page equals home. So page is the key, and home is the value, and this is a URL parameter. The use of URL parameters which reference other files on the web server could potentially be exploited in an attack called local file inclusion, otherwise known as LFI. So local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities can lead to sensitive data exposure and can also be used as the first step in a chain of exploits. The inclusion of file names and URL parameter is a typical method through which a potential LFI vulnerability is identified. So over at the Natas 7 landing page over here, so we click on this and it says index.php, and then there's a parameter page equals home, and it says this is the front page, but we see here that the home file is being supplied as the one to be displayed by the web server. What we can do is we can do an escape, and we escape by using these ... characters. So each time we do a ... character in the payload here, what we're going to do is we're going to move up one level inside of the web server working directory. So what does that mean? Let's explain. Cymer Dante, search equals Q equals slash ... etc. Password. That's not going to work on Google. At least I really hope it doesn't work on Google, because if it works on Google, then we are in big trouble. ... Let's try. Let's hack the Google website live, everybody. Let's take a look at the etc. password file. Nope, doesn't work. Okay. Anyways, let's go back to the actual vulnerable website. No. That's not. If that works on Google, you're making like 10K. If that works on Google, a bunch of well, okay, not very many people are watching my stream, but if any hackers were watching my stream, then they would be able to do all sorts of bad stuff with that vulnerability, is what I'm trying to say. Okay. So why are we using all these ... slashes? You are going to jail. Well, that's why I was hoping that the Google security team was on top of their game. So why are we using all these ... slashes? Each ... slash indicates an elevation of one level in the file system, traveling from the web app's working directory, which is /Natas7, up to the top level directory, which is a slash directory. So we move from Natas7, the next ... slash moves us to Natas, the next one leads us to labs, and then var HTML, then var, then the top level. From the top level directory, we can provide a file path to the file that we want to access. A typical test file for LFI on Linux Unix web servers is the etc. password file, since it is publicly readable by default and gives info regarding the usernames on the web server. So if we go over to this website here, and we supply a bunch of ... slashes and then etc. password, then we see all of the users on the web server over here. So Let's make this a little bit prettier. We can make this prettier by looking at this in the view page source view. So we can actually scope out right here that there are 34 levels in the Nadas game because there's a user for each one of these levels. All right, so password for web user nadas8 is in /etc/nadas_webpass nadas8. So this is the file we need to access in order to get the password for level 8. So all we need to do is copy this file path over here and then go back to our URL. So the payload, we're going to switch from etc password, and we're going to paste in the actual password for nadas8 in here. Okay, so amongst the output here is this string right over here, and this string is the password for the next level, nadas8. So let's copy that. If anybody's interested in it, then I'm going to paste it in the chat for everybody. Okay, and then we can access the next level. So all we need to do is just clear everything off and modify the URL from nadas7 to nadas8. It's going to ask us for the username. It is nadas8. And the password is also, well, the password is not also, it's this thing that we copied. Then we sign in. Okay, so it says here, input secret. Let me check with my notes. Oh, okay. All right. So we're talking about more source code analysis in this level, and oh wow, we're doing pretty good time right now. All right. So Nadas level 8 over here. Input secret, and then we can submit the query. So if we do test and click on submit query, it says wrong secret. We also have this source code right here. So let's take a look at the source code. It's obviously what we need to do to solve the level. Put it in a new tab. And then this is the code we need to look at. So this is once again PHP code. And can anybody tell us how we can tell it's PHP code? Cyberner Dante is correct. It's because of these opening. I guess what would you identify these as? Okay, let me ask ChatGPT real quick because I don't know. In PHP code, what is this called? And then provide this. It's an opening tag. Okay, so it's a PHP short open tag. All right. So the standard PHP tag is bracket question mark PHP, but the short one is just bracket question mark. Okay, great. Okay, so what's going on in this code? So we can try to figure this out ourselves. And we should, if you really don't know what's going on, we could copy and paste this code and provide it to ChatGPT and ask it for an explanation. I don't think we need to do that in this case. We can probably figure it out ourselves. But the first thing here is the encoded secret variable here. It's equal to this string. GoPux says it's just base64 encoded combo. Is it? Wait, are we talking about this, or are we talking about something else? So the encoded secret is this. It looks like hexadecimal. So this is and hexadecimal can be mistaken as base64 as well. So okay, so we have the secret over here. It's this it says over here, is it hexadecimal, is it base 64? Let's take a look at the function. So there's a function definition over here for encode secret, with secret as the parameter. So secret is the parameter, not encoded secret. So this is not the same thing. So encoded secret and this thing secret is not the same thing. So we are going to do a bunch of different things to this secret parameter over here, right? So the secret parameter first, so we're reading from right to left, not left to right. So normally we would do this and then this and then this, but what's going on is that this piece of data has this run on it, and then this, and then this. So the secret data is going to be base 64 encoded, then it's going to be string reversed, and then it's going to be binary to hexed. So it's going to take the binary code, the binary version of the information, and it's going to turn it into hex code. So this is actually the result of this function right here. So what does it do with it? So if array exists, submit post. So if the submit field is not empty, then it's going to post the information. If the encoded secret, if we run this function encode secret on whatever we send in post, and it's equal to encoded secret. So basically, if the encoded secret and whatever we send as the secret in the post request, if they're the same, then it's going to print access granted. The password for Natus9 is this. Otherwise, it's going to print wrong secret. So in order to figure out what the encoded secret is actually supposed to be, we need to reverse this function over here. So this is called source code analysis. So what we need to do is we need to reverse the operations for all these functions. So for example, we've got our original operation, which is bin to hex in the original function. We need to provide the reverse operation, which is hex to bin. So the next one is the string reverse, with strrev. The reversed operation is exactly the same. It's strrev. And we've got base 64 encode, and of course the reversed operation for that is base 64 decode. So what we can do is we can figure out what the original secret is by going over to the page here and getting this entire PHP snippet. So after we do that, we can go over to some online PHP website, like PHP Online. So PHP Online, this is a sandbox, okay. Let's see if we can access this site. It looks like it's acting extra slow. Okay, so to everybody who's interested in following along, it's https://onlinephp.io. Hopefully that's the right thing. Okay. Oh, it still has this saved from the last time I did this lesson. Anyways, what you want to do is you want to go over Cyber Dante, could you zoom in just a smidge on this page? Yeah, I can certainly do that. Just a second. So we need to get this code. Copy it, and then go over to the PHP sandbox. So we're going to paste this in. I'm going to make it nice and big. Oh, geez. Maybe that's too big. Okay. And what we need to do is we need to adjust the code.
So first of all, these lines of codes can go completely away. So you can highlight everything from line 9 until the bracket on line 15, and you can just get rid of that. So just delete it. So afterwards, what we're going to do is we're going to go over to encoded secret, and we're just going to call this secret. So secret over here, and the function here, we're going to rename the function. We're going to call it decode secret. So decode secret with this function with this parameter secret, which is this. What we need to do is we need to change the order. So base64 encode needs to go over here, and bin to hex, the reverse of that, has to go over here. So bin to hex, we're going to change this into base64 underscore decode, and base64 encode at the beginning here, we're going to turn it into hex to bin. So the first thing that's going to happen is the hex information here is going to be turned into binary, and then the binary string is going to be reversed, and then it's going to be base64 decoded from this. Okay, so if anybody wants to know what anybody wants the easy version of this code right here, you can find it in the GitHub file over here. And let me just grab the link. So if you want to take a look at the code we're using right over here, just scroll down until this part over here. You can copy this code, and then you can plug it into your PHP, your online php.io if you like. So let's just paste it in. The last thing we need to do is we need to actually print out to the console. So we're going to use the echo function to do that. So we're going to echo decode secret with the secret variable here. Okay, so after we do that, we can run this code. So we can just click on execute code down here, and we get this string over here. So what we need to do is copy this string and feed this to Natus level 8. So over here, input secret, paste in the code, paste in the string that we got from the from running the code, click on submit query. It says access granted. The password for Natus 9 is this thing right here. So copy this, and this will be the password for the next level. I don't think we're going to be solving the next level, but we can go ahead and try logging into the level anyways. So username is Natus 9. Password is pasted in, sign in. No, it doesn't like this. Natus 9, paste in the password. This is wrong. That can't be right. Hold on. Okay, so let's try logging into Natus line 9 one more time. Username Natus 9. Paste in the password, sign in. Okay, I must have copied something incorrectly. But yeah, this is Natus level 9. We're not going to be doing this level tonight, but this is going to be for next time. What we're going to be doing is we're going to be solving some PicoCTF challenges that have to do with the stuff that we are looking at tonight. So let's see. Right. Okay. So what challenges are we going to where are we going to cover tonight? Well, let's close out these Natus 9 tabs first. So let's see. The first challenge we're going to do is the local authority challenge. If you don't have an account over at PicoCTF, you can go ahead and navigate to this page. You should see a sign up link if you're not logged in to your PicoCTF. If you don't have an account, let us know and we'll wait up for you. We'll wait up for you and hopefully you can join in and solve the challenges with us. So these are web challenges, so we don't need to start up a web shell, which is nice. So what we're going to do is access this challenge called Local Authority. The link is in the chat. Okay, and the Local Authority challenge says, can you get the flag? Additional details will be available after launching your challenge instance. So everybody, if you can solve these challenges before I can, then go ahead and do that, and let us know in the chat that you're an awesome hacker person, because if you can challenge yourself and get the flag before I show you how to do it, then that's a good thing. Okay, so the first thing we need to do is we need to launch the challenge instance, which is a cloud machine that hosts the website. Click on Launch Instance. And then after a few seconds, then you'll see the button over here turn red. And we'll have about 15 minutes to solve the challenge. So it says go to this website and see what you can discover. So we can go over to the website. And it says here, secure customer portal. Only letters and numbers allowed for a username and password. Oh, okay. Okay, so, So we just do test, click on login. It says login failed. Okay, so it says login failed over here, but maybe we should take a look at the source code. So in the source code, we see source equals secure.js. So this login page over here is using code from secure.js. So we should probably take a look at that. So we can, Can we put this in a new tab? Well, I guess we can copy the link. And then we can take a look. Okay, so the function password check. For a function check password, username password. So this is not, I think this is JavaScript now. I'm not too sure if this is JavaScript because it's a JS file. But if username is exactly equal to admin and password is exactly equal to strong password this, then return true, or else return false. So if you know Python, if you know PHP or some other programming language, this all looks very, very similar, except they use these triple equal signs instead of the double equal signs we usually see in Python. But anyways, this points us to the fact that we're supposed to use this username and this password. The username we can probably remember, but the password we can just copy. And then go over to the website, and then go back and try logging in again. So the username is admin, password is pasted in, click on login, and we're done. So this is the flag. Copy the flag, then go over to the challenge page, paste in the flag, and you are done. Okay, so if you managed to finish that challenge, local authority, please type in the chat, localized, smiley face. All right, let's move on to the next challenge. Simon Dante says, just started it. No worries, no worries. Yeah, if you need a little bit of time to catch up, we'll try taking our time starting up the next challenge. So the next challenge we're going to do, we've got 2 more challenges to finish off today's lesson. So we got forbidden paths. And you can access forbidden paths from this link over here. Okay, so the forbidden paths challenge here. The description says, can you find the flag? We know that the website files live in /user share nginx HTML, and the flag is at /flag.txt. But the website is filtering absolute file paths. Can you get past the filter to read the flag? So let's start the instance. Start the challenge, we need to click on the Start Instance, Launch Instance button. And that's going to start up the website. So after a few moments, we're going to see the instance time remaining over here. It's 14 minutes or so. And in the description, there's going to be a link to the website. So just right-click and put it in a new tab. And then navigate to the website. So it says here, web e-reader, divinecomedy.txt, olivertwist.txt, thehappyprince.txt. So this is, if anybody knows what kind of vulnerability is on this app, then please let us know in the chat. Otherwise, I'll be talking about it in just a little bit. Marco Pulisic asks, hello, how are you doing? How are you? What are we doing? Okay, so what we're doing right now is we're doing some challenges on the PicoCTF website. And the challenge we're taking a look at right now is this one called Forbidden Paths. If you have an account over at PicoCTF, you can run the challenge along with us. So it says here that this is a web e-reader, and we have some, it looks like these are file names that we can type in. So for example, we can type in olivertwist.txt, and that's going to retrieve this file over here. So the thing is that there's a vulnerability on this website. Does anybody know which vulnerability it could be? I'll give you a hint. It's a vulnerability that we covered in today's lesson. Neospring says Ribbit. Hello and Ribbit to you as well, Neospring. Just for fun, let's run a redeem. Let's redeem the Northern Flicker. So this is my favorite woodpecker. So you might be able to see the Northern Flicker woodpecker on my overlay. And Marco Pulisic says it looks like cross-site scripting. Cyber Dante says we're trying to crack a local file inclusion. So the answer is local file inclusion. So usually you don't see local file inclusion in a user field, in a user text field like this. Most of the time when you see the typical local file inclusion, it's going to be in the URL over here. But this is a local file inclusion vulnerability, so what we can do is we can escape the current directory. So the current directory has text files like this. We could test for LFI inclusion by sending some sort of test payload like this, and we can provide the name of a common web server file like etc password. Directory traversal, directory traversal, right. So sometimes it's called directory traversal, but the way I was taught was that it's called local file inclusion. It's basically accessing files on the underlying web server from a website interface. So if we do dot dot slash a bunch of times and then etc password, and we read this, then this is the contents of the etc password file on the web server. So this is evidence that we have local file inclusion on the app. And if you remember, in the description over here, we know that the web server lives in user share nginx HTML, and the flag is in /flag.txt. So what file path should we feed to the website in order to gain access to the flag.txt file? If you know, type it in the chat. So in this case, to access the flag.txt file, so this series of dot dot slashes are going to bring us up to the top of the file system. And because we're at the top of the file system, we can just provide the name flag.txt and read that. And this is the flag for this challenge. So copy the flag, go to the challenge, description page, paste in the flag, click on submit flag, and we are finished. Okay, so everybody, if you managed to successfully finish that challenge, please type in the chat LFI FTW, smiley face. Marco Polisic asks, how do you know how many dot dots to put? So the in most cases, you can put, you just need to make sure that there are more than the number of directories that you're down. So over here, so user share nginx HTML, so that's 1, 2, 3. We only need to provide 3 dot dot slashes, but if you provide more than 3 dot dot slashes, it's not going to make, it's not going to affect the result. So you can add as many dot dot slashes as you can. So you could do 7 or 8, that's fine, because it's still going to put you up at the top of the file, at the top of the file system. LFI is fun to find. Yeah, I actually like LFI, local file inclusion, a lot, because it's basically, if you know a lot about the default file systems, you can be rewarded a lot when you're using local file inclusion vulnerabilities. But let's do the last challenge for the day. So the last challenge for today is called Don't Use Client Side. So it is at this URL, which I provide in the chat. So this challenge is called Don't Use Client Side. It says, can you break into the super secure portal? So there is a link over here, and there's a bunch of different links, but they all go to the same place, I'm pretty sure. So you can go ahead and try accessing this link. So you don't necessarily need to be logged into PicoCTF to do this challenge. But let's... Okay, so it says here, this is the secure login portal. Enter valid credentials to proceed. So I guess we can just type something in, test, Click verify. It says incorrect password. Don't save that, please. Okay, so wow, this is super bright. I'm going to take a look at the HTTP source. So I'm just going to use the Control U keyboard shortcut, and we see that there is JavaScript here. So script type equals text JavaScript, and there's a function called verify. So otherwise, so the problem here is that it's running a bunch of split up JavaScript code, little snippets of strings. So what we need to do is we need to figure out what the original string is to put into the web app. So what are some does anybody have any suggestions as to how we would find out what the original string is? So this string is all split up. We could do this manually. So we've got the number 0. We can just regroup all the substrings. Yeah, we could do that. So substring 0 is this over here, Pico. And then judge it by the split number. Right. So there's split to split 2 is CTF, this. And we can do split 3. Where is split 3? Split 2 to split 3 is this. Split 3 to split 4 is this. Split 4 to split 5 is this. Split 6 to split 7 is this. So what I would do is I would just feed this to ChatGPT because ChatGPT can probably give this to be much faster than doing it manually. Okay, so what I would do is I would just go to ChatGPT and please look at the following code and concatenate all the strings, all the split strings together. And then paste in the code. You're giving me a lot of text. So this is the finalized password. You can do this manually. It's a pain in the butt, but it's good to know how to do it manually. This is something I would usually pass over to ChatGPT. But we can go back to the challenge. And then, actually, this is the flag, but if you go over to the challenge, you can actually submit this and then click on verify. And then it says password verified. But it doesn't give you a flag because the flag was the actual password. Summoner Dante says, yeah, obfuscation is never pretty to look at. Nope. No, it is not. But anyways, let's solve the challenge. Go back to the challenge description here. Paste in the flag, click on Submit Flag. And then we are finished. Okay. All right, so before we finish out today's class, let's take a look at a summary of the concepts we took a look at in this workshop. So let's review the web app concepts that we learned in this workshop. So just so everybody knows, I don't use the word web exploitation I don't use the word exploitation anymore when I talk about hacking because YouTube doesn't like it, and YouTube will actually not recommend my videos if I use this word in the title of the video. So I just don't use it anymore and replace it with something else. That's what's called a hack. So we talked about source code analysis. Source code analysis is the process of analyzing the code of a piece of software with the goal of deeper understanding regarding its function. It is a common technique used in software security testing, but it requires that the software source code be readily available. We talked about URL parameters. URL parameters are variables attached to the end of URLs. They're often used to send search queries to web servers, but they can be used to retrieve other data as well. When we learned about local file inclusion. Local file inclusion, otherwise known as LFI, sometimes it's also called directory traversal. It's a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities are typically identified when file names appear in URL parameters when accessing web pages. But as we saw in one of those challenges, it doesn't necessarily have to appear there. So basically, anytime you see that you're inputting the names of files into either the URL or inside of a submission field in the app, that might be a sign that it's that the app is vulnerable to local file inclusion. So what's next? In the next HackerFrogs After School web app hacking workshop, we're going to continue learning web app hacking skills with the NATA-CTF. Notably, in the next lesson, we're going to be talking about OS command injection. So OS command injection is a pretty interesting vulnerability in web apps where you can send OS commands like Linux commands or Windows commands through the web app. And it's going to be really interesting. We're going to be talking about it on Friday, so please watch out for that lesson. It's going to be on Friday at the same time. Okay, so that means that class is going to let out a little early today. But thank you very much for everybody for coming and participating in the HackerFrogs web app hacking workshop. User agent, who am I? Yeah, that could be one. Thanks for streaming. We're not done. Cyber Dante, we're not done. We're going to be doing one last section in today's stream. We're going to be doing some free hacking against one target over on the VulNyx website over here. It's machine number 58, first. Marco Polisic says, I wish your classes weren't at the same time as my school classes. Well, you can always watch the recording afterwards, but yeah, I'd like to try starting my classes a little bit later, but I need to make sure that it's at a good time for the majority of the students. Marco Ballistic says it's not the same feeling as live because you can. Yeah, I think that live streams are really good because you can ask the presenter questions and you can get your questions answered. You can also make comments, and I definitely feel what you're talking about. But thank you for coming to class. We're going to be switching up our content for the next hour or so. We're going to be doing some free hacking against this vulnerable virtual machine over here. And if you want to take a look at this machine, you can take a look at this website here. Let me turn on my music again. So in order to hack against this target, we need to start up the virtual machine on our network. So I'm starting up the machine. It's over here. It's going. And let's celebrate the last part of our stream with some Hack the Planet.
Hack the planet! Hack the planet! Shut up and get it.
Okay, so we see that the first VM is running at IP address 10.0.2.47. So that's the target. That's the IP address we're going to be hacking against. Let's start hacking. Let's get rid of the stuff that's already here, and let's run an Nmap scan. So as you may or may not know, Nmap is a program we can use to scan servers, remote servers on our network, and we can determine what networking ports are open and not open depending on the results of the scan. So we run it with -sc to run common scripts against services we find, -sv for versioning information, -p- for to scan all ports, -vv for very verbose output, and -t4 to run it very, very fast but not too fast. Okay, so let's start our scan. So we find 3 TCP ports open on the system. So let's take a look at what we found. We found port 22 open, which is the SSH service, running SSH version 8.4. This is a relatively up-to-date version of OpenSSH, so it's probably not vulnerable to exploits. Port 80 is running HTTP, which is running an Apache server with version 2.4.56, which is also relatively recent. So it's a relatively up-to-date version, so it's probably not vulnerable to exploits. And there's port 4369, which is running an Erlang port mapper. So I don't know what an Erlang port mapper is. It's a new technology to me, so I'm going to have to learn about it while I'm doing my hacking against it. So first of all, let's do some enumeration against the web port before we try hacking against this this Erlang port mapper. Okay. The first thing we're going to do is we're going to run Nikto, which is an old piece of software. It's a web app vulnerability scanner, and we're going to run it against the web port. So the web port in this case is port 80 at this IP address. This can give us some low-hanging fruit vulnerabilities, and if they are present on the system, it'll give us a lot of generic information such as the server version number, and the software being used, and the HTTP methods being used as well. Unfortunately, we didn't find anything too concrete here, but the next thing we're going to run is a DIRB scan. This is relatively easy directory busting. So we're going to try to determine what directories exist on the web server by running this tool right here called DIRB. But it was only able to find the index.html file. So server status, we're not able to access this. It gave us a code 403. So the next thing we would do is we would run a more robust directory busting program, such as GoBuster. So GoBuster is a more modern directory busting program. We can use it to do directory fuzzing as well as subdomain enumeration. So we're just going to run this to see if it can find any directories and or files with these file extensions over here. So we supply the x the x argument with a bunch of different file extensions. We have to keep in mind that each one of these file extensions that we give to the program is going to extend the amount of time that the scan takes by 100%, because it's going to use the same word list, and it's going to try using each one of those word lists with this extension as well. So it's gonna, if you give too many file extensions to GoBuster, it's going to take a long time to come back. But let's just run this. So it finds index.html. So because we know that that this web server exists, we can manually enumerate it using a web browser. So we can just go to our web browser and then go to 10.02.47. Oh, this is a Debian default page. So most of the time when there's a web server but there's no website here, you're going to see something like this. Cybernerd Dante says FFUF is my favorite, but they all work really well if you know how to use them. Yeah, FFUF definitely has its very useful for doing fuzzing on a particular part of the URL. So if the URL has a part that you're trying to fuzz, make maybe some numbers or some parameters or something, then the FFUF program is very useful. But I've gotten used to using GoBuster, so it's usually my go-to when I do directory busing, fuzzing stuff. Sometimes there are some clues left in these Debian default pages, but I don't think this is the case. So sometimes they'll have some notes in these default pages, but all the stuff that I've encountered on the VulNyx website is they don't really like putting hints in here. Okay, so I don't think we're going to find anything in the web server, so we can just leave it alone. We'll keep the scan going, but we're going to try to investigate the other port. And the other port we found was the port. It's 4369. Okay, so I don't know. So I think it was called the Erlang port mapper. I don't know anything about this. So what I'm going to do is I'm going to go over to Hacktricks. And Hacktricks is a resource that I use very often. It's written by the same authors who did the WinPs and LinPs privilege escalation scripts, so they know what they're talking about. I think the author's name is Carlos Polop, but there's on this website there is a little search bar, and you can search for whatever technology you want to hack against. So this one is called Erlang, and there's an article here, so I can just click on this and take a look at what techniques we can use to hack against this service. So it says here, serves as a coordinator for distributed Erlang instances. I don't know what that means. It is responsible for mapping symbolic node names to machine addresses. Node names to machine addresses. So it's some sort of DNS. Essentially ensuring that each node name is associated with a specific address. The role of Erlang port mapper daemon is crucial for the seamless interaction and communication between these different Erlang nodes. Okay. All right, so RabbitMQ and CouchDB installations. So what can I do for enumeration? I'm not too sure what we're talking about here. But I can try connecting to the machine via netcat like this. I think that's what it's trying to indicate. Okay, so let's give this command with the IP address 47. Okay, it says that it's open. It says it's open. It doesn't tell us anything else. Okay, well, Once Erlang is installed, this will prompt an Erlang terminal. What is... I'm not even sure what that means. Okay, so apparently there's an mmap script as well. Can you straight up connect with Netcat? I can try. So let's just try connecting with Netcat here. Okay, so let's see if it... Yeah, let's see if it gives us a banner. Sometimes it can take a little while for these banners to show up. But yeah, it doesn't respond to regular old Netcat. So I might need a specific client to interact with the service. So there's also this nmap script we could try. And I guess we could get... I don't even know how to read this stuff. But, well, we could try. We could give this a try. Okay, so let's use the nmap script. 47. Okay, I'm going to ask ChatGPT. Hold on, ChatGPT. I want to interact with the Erlang port mapper service via command line. What program should I use? EPMD command. Okay, so is this installed by default on Kali Linux? EPMD. So this is, it looks like it's not installed. So the script came back and didn't give us any information. That's, did I get versioning information from my last nmap scan? Hold on. So I didn't get any versioning information from mmap. Gopux says, I think there was a program on HackerFrogs. Yeah. Let's, okay, so HackerFrogs, where are we? Are we here? ERL. Okay, so apt-get install Erlang ERL. ERL. Yeah, this is not installed. But it's not exactly the same program that ChatGPT suggested, which is the EPMD command. Let's try the one on HackerFrogs. So HackerFrogs is apt-get install Erlang. Sudo apt-get install Erlang. Okay, I need 145 megabits to install this thing. Okay, sure. Oh, man, I'm having some problems. Hold on. I think sometimes when you're trying to install a program, you need to turn off your antivirus because for some reason some antiviruses have the Kali Linux oh, what was it called? The sites, they have them blocked, so you have to Let's try. Okay, I just turned off my antivirus. Let's try that again. Huh. Maybe try run apt-get update or try with fix missing. So let's try it with fix missing. Fix missing. Aborting install. Maybe some of the pages are outdated? Could be. Yeah. So maybe that that program is not going to install properly. I'm going to turn my antivirus back on because don't want to leave it off. Okay, so let's try that again. Let's try installing the package that ChatGPT was suggesting. So EPMD. Okay, so let's try EPMD. Can be installed. Install Erlang base. You want to install it. So this is much smaller. Unable to fetch. Not found. Huh. I wonder if I could just download download some file, some Erlang file that I could just run. EPMD ERL. Okay, let's try to do some live debugging. I'm gonna try to figure out why this isn't going to install. Failed to fetch. Right. Okay. So not found. Maybe I need to. Yeah. Maybe I need to do sudo apt get update. So I'm just gonna update all of my packages over here. This is super exciting to watch. All right, so while this is going on, maybe I can put on some fun videos for you to watch. So this is so these are my precious Stellar J birds at the bird feeder. This one, this is from last summer. This guy has a broken leg, so he's a bit awkward when he's at the feeder. Oh, did this finish? Oh, it finished. Okay, I don't need to show you bird videos. All right. Now let's try installing this again. Okay, so hey, it works now. Great. I just needed to update my my packages. I'm sure glad I didn't have to have everybody watch my my lovely Stellar Jays eating at the feeder. Anyways, okay. I'll you guys don't need to watch this. Okay, it should finish. It should finish installing in a few seconds, hopefully. Okay. All right, we've got it installed now. So how do we use this program? So if you want to interact with the Erlang node itself, you can just use ERF shell to connect to the node by specifying its name and cookie. ERL name, node name, set cookie, cookie value. I don't know how to do any of this stuff. So check EPMD status, EPMD names. Cannot connect to local EPMD. So how do we connect? Kill the process, stop C. Ensure that EPMD is running on both local and remote hosts, as it is essential for node discovery and connection. Oh, okay, so I need to start it as a service or something. Okay. I just finished installing EPMD on my system. I know that the Erlang port map service is running on port. What port is it running on? What port is it running on? 4369, okay. 4369 on IP 10.0.247. How can I connect to it? Okay, to connect to the Erlang port mapper daemon on IP, you can use netcat or telnet to establish a raw connection and query information from EPMD. This can be useful for inspecting active nodes or manually interacting with the service. Well, this didn't work. Maybe it didn't work because I used the wrong command. So sending a names query can retrieve a list of registered Erlang nodes. Okay, so let's try this. So using telnet, this didn't quite work. Alternatively, you could use EPMD directly on the command line with the names flag if running commands directly on this IP address is possible. Okay, so let's try this instead. Oh, that just didn't work. So EPMD port number is this syntax incorrect? EPMD syntax. Okay, let me do a quick Google search. EPMD command syntax. Okay, so let's see, regular options, debugger options, interactive options. Okay, so port names. Okay, so I think there's another, so I think it was called bro just EPMD. Nope. Okay. So the next thing I want to ask is, hey ChatGPT, are you sure this is the right format? This syntax. Please double check. the epmd command syntax. Once connected, you can send raw queries to epmd, for example, names. Okay, well, let's try sending the names command with netcan. Nope, it doesn't like that. How about this? No, it doesn't want to do. It wasn't. It doesn't want to cooperate. Okay, let's look back at hack tricks. So automatic epmd info. So we weren't able to get this to work. Remote connection. If you can leak the authentication cookie, you will be able to execute code on the host. Usually this cookie is located in Erlang cookie and is generated by Erlang in the first start. If not modified or set, it is a random string with the length of 20 characters. Erlang cookie. I don't think we're able to access this from the web, but I guess we could try. So it's .erlang cookie. So if we go over to here it is. Okay, so HTTP .erlang cookie. Nope, it wasn't found. Okay. Okay. Local connection. Metasploit. Metasploit can also exploit this if you know the cookie, but we don't know the cookie. So if I remember, Copux, you asked Copilot, okay. So epmd-daemon. Alright. Let's give it a go. epmd-daemon. And then epmd try to connect to this thing. Nope. Did this give... I want to run this one more time, just to make sure that it's not giving us any... Wait. Was there an endpoint called task list there? Oh, okay. There was an endpoint here. Task list: go shopping, make coffee, update Raspberry, go hairdresser, request salary increase, clean my room. So what is Raspberry? So in the task list it says update Raspberry. So first of all, I can try running a GoBuster scan inside this directory called task list. So let's try task list. Okay, so update Raspberry. What is Raspberry in relation to Oh, okay, so it could be running EPMD on a Raspberry Pi. All right. Okay. Raspberry as a node name. Oh, okay. Raspberry might be used as a custom node name for the distributed Erlang system running on a Raspberry Pi. For example, if you were setting up an Erlang node on a Pi, you might start with a name like... Okay. If you come across Raspberry in documentation of the product... Okay. So Raspberry could be the node name. If we know that Raspberry is a node name, how can we use this to enumerate, to run Erlang commands? If Raspberry is the node name, you can use it to connect to Erlang node and run commands. You need the node name and the cookie that allows authentication between Erlang nodes. Connect to the node. Okay. Ping the Raspberry node after connecting. Check that you can communicate with the Raspberry. Run commands on the node, on the remote node. Okay, so alternatively, you can start a remote shell directly on Raspberry node to run commands interactively. Okay, so the problem is that we don't know the secret cookie code, because we need the cookie code in order to connect to the machine. So scanning inside task list didn't get us anything so far. Can I interact with the Erlang port mapper service at all if I don't know the cookie value? Yes, you can still interact with the Erlang port mapper daemon itself even if you don't know the cookie. The cookie is required only for direct communication with Erlang nodes, not for querying EPMD. Here's what you can do. EPMD names. Locally on the machine. Okay. Remote EPMD query. If you can't run, you can use tools like Netcat. We can't use tools like Netcat. Okay. Formatted in EPMD's binary protocol. Without the cookie, you're limited to querying EPMD for node presence and basic metadata. how can we use netcat to send the names command through as a one-liner command? D-Dubs on YouTube, hello. First time, what's going on? We're just doing some, we're just running a hacking exercise against this, this system over here. It's called First, and you can locate it, if you want to join in, it's available on this website over here. It's called VulNyx. It's a site where you can download virtual machines to hack against, and this machine is number 58 on the list. But we're getting stuck because we're hacking against a service we've never come across before. It's called the Erlang Port Mapper service. So I'm just asking ChatGPT about how to interact with it. You need to format the request in the specific binary protocol that EPMD expects. So here's how you can construct the one-liner with netcat. Echo this to, oh, okay, oh, all right. So this is what the Hactrix was doing over here. Is this the same thing? I don't know if it's the same thing. Once Erlang is installed, hacking seems interesting learning Linux. Yeah, well, you don't need to use Linux to do hacking stuff. Some people do hacking completely inside of Windows, but a lot of people choose to use Linux for their hacking because there's specific versions of Linux that are catered towards cybersecurity, such as Kali Linux, which is the one that I'm using right now. But yeah, Linux. I mean, it is fun to work inside of Linux, just as a personal opinion. NetADM names. Okay, so let's try this and see what happens. Kali Linux. Right. So let me point you towards Kali Linux if you've never taken a look at it before. D-Dubs, do you know how to use virtual machines? Do you know how to use stuff like VirtualBox or VMware? Get Kali. So if you wanted to get a Kali Linux virtual machine, you could go over to this website, and it'll let you know all the installation options for virtual machines. So usually you would do something like a VM over here. Okay, so let's try 247. So it says unknown, this thing is open. Okay. Okay, so this tells us if it's open, but the other command that we got from ChatGPT is going to give us the names. Okay, let's see. This doesn't give us anything. Wait, what's the difference between... This looks like the same binary. Oh, I guess I need to provide it with verbose mode. So this doesn't tell us very much. It only tells us that the service is open. Okay. So what other commands can we send as one-liners through netcat? Oh, go ahead and think about that. Okay, so EPMD. So we haven't gotten we haven't gotten anything from this EPMD server so far. Maybe we can do it. We can look for an EPMD cheat sheet online. EPMD cheat sheet. OSCP, EPMD. How about looking for something instead of EPMD? We can look for Erlang. Erlang port mapper. Okay, so Erlang OTP cheat sheets. Okay, so map list binary. Okay, so what is ChatGPT telling us? It's not telling us anything. It's not telling us anything. Okay. I'm going to reload this. Okay, accept several commands, and these commands are sent in a specific binary format. We've already covered. Okay, so it gave us example with multiple commands. Get the version of the EPMD server. Oh, this could be very useful over here. So if we could get the version, we can try figuring out if we get the version of the service, we could try to figure out if it's vulnerable to any exploits. Let's send it with VN. This doesn't give us anything. This looks like the same. This looks like the same payload as last time. Get the version 76. Didn't I just send that? Ping. So use to check if the node is reachable. Binary format 70. All right. This is giving us nothing. You can send a sequence of commands in one echo statement, occurring for both the names and the version. List of registered nodes. Get the version, right? Register a node. Deregister, get PID. Okay, so let's take a look at the HackerFrogs website again. Once Erlang is installed, this will prompt an Erlang terminal. Okay, well, let's try this. So ERL ERL. Okay. Let's try the host. The host is this. Okay, so this doesn't work. Let's instead ask ChatGPT, what if we want to send commands using the ERL terminal instead? Okay, start the shell, connect to the node. So ERL, to connect to the Erlang node, you can use the sname or set cookie options. So here's an example where you can connect to a node named mynode. ERL. So let's try this with the Raspberry name. So this would be sname Raspberry. It didn't give us anything. Okay. Let's try it with the capital R. Nope. Was it caps? Was it caps? That's a good question. So it was just this. Update Raspberry. Let me check with So GoBuster didn't find anything inside of the task list directory. Just for fun, let's scan this directory again with GoBuster because I didn't pay enough attention when I was looking at it last time. Okay. Automatic. So the port mapper info didn't give us anything. Cookie RCE. So remote connection, if you can leak the authentication cookie, you'll be able to execute code in the host. Usually this cookie is located in Erlang cookie and is generated by Erlang at the first start. If not modified or set manually, it is a random string with a length of 20 characters. Okay. So ERL cookie, your leak cookie, name, okay, so more information, we can do the Erlang distributor RCE and cookie brute forcer. So there's a program to brute force the cookie, and I'm interested in getting this. Cookie. So let's try this brute force program. Okay, let's take a look at another tab. Oh geez. Okay, so where is the script to brute force the cookie? Okay, is this it? Okay, let's copy this link and let's see if we can use this brute forcer program. So let's get that. That's get that file. Wait. I don't think that was the file I wanted. Okay, let's try downloading that file. Okay, we downloaded it. Great. Let's copy it to our directory. So let's see. Move from downloads. This one is called. What is it called? EPMD. Okay. Now let's BZ2. 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 Okay, how do we unzip BZ2 files? BZ2 zip, okay. B unzip 2. All right. Okay, so that means it's a tar file. Tar unzip this thing. Okay. So what kind of file are we dealing with? I'm used to dealing with Python files. I guess these are... Okay, so this looks like... So we've got ebin priv source. Don't suppose there are instructions over here? More information here. The author also shared a program to brute force the cookie. We're trying to install a program or script when unzipped. File includes the following directories. The directories are ebin priv src, ebin priv src. It also includes the files emakefile, makefile. Okay, so this... Oh, this is an Erlang application. Okay. Let's see. Steps to install or compile the program. If you're trying to install or run this program, you need to compile it first. So check dependencies. Make sure you have Erlang installed in your system. Okay. Using make. So if the project includes a make file, it likely uses a Unix-based make tool to manage the build process. So we need to compile this. Interesting. So we just need to run the make command. If the project supports installing, you might use sudo make install. So if we just go over to the directory here and we use the make command, it gives us an error. Let's get rid of this crash dump file. Let's try the same thing with sudo. Sudo make install. Let's just run sudo make. Didn't work. Using emakefile. If the project uses Erlang specific build tools, If the project uses Erlang specific build systems, follow these steps. Using rebar 3, you need to install rebar 3. I need to install more software, jeez. Using emake on older systems. If the project is old and relies on emake file, use the following commands in the project directory to compile the application. erlc-make. 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 This didn't work. So, if there is rebar 3. Okay, you know what? We found this task list. We found task list. And when we take a look at task list, it says update Raspberry. So is Raspberry a potential user on the system that we could try to brute force? Because if so, then that would be really funny. And we could try to brute force using something like Hydra. So let's just try Hydra and try to break in with the user Raspberry. Okay, so because we don't have too many more options. Go shopping, make coffee, update Raspberry, go hairdresser, request salary increase, change, clean my room. Okay. Okay. If you can leak the authentication cookie, you will be able to execute code on the host. Usually this cookie is located in Erlang cookie, generated by Erlang at the start. So random string A to Z with the length of 20 characters. We can't create a word list this big. 20 characters with a random string A to Z. That's too big. That's too large a key space. But we're not getting anything out of the system so far. Erlang cookie RCE. Metasploit can also exploit this if you know the cookie. But we have to know the cookie. Okay. So if we do, let's search exploit for Erlang. So Erlang port mapper daemon cookie remote code execution, right? Erlang cookie remote code execution. Erlang cross-site scripting. Okay. Okay, let's go back to the drawing board So if we could get this program to brute force the cookie to work, then we would be in business. So eMakefile, makefile. Let's take a look at this eMakefile first. And then let's take a look at this makefile. Okay, so once more over ChatGPT. Ensure Erlang is installed in the system. Use make if the project includes a makefile. Use rebar 3 if the project uses eMakefile or is managed with rebar 3. What's in the ebin? This file, that's a bunch of binary stuff. So I'm going to try and see if I can install these programs. Use rebar 3 if the project uses eMakefile or is managed with rebar 3. Run rebar 3, compile. Compile Erlang code using ERLC or rebar 3. Okay, so using emake, ERLC make, use the following commands in the project directory to compile the application. ERLC make. This will compile the Erlang source code files and create the necessary .beam files. If the project is managed by rebar 3, a common Erlang build tool, you need to install this. Okay, let's try installing this program. This is getting away from us. Okay, we downloaded the file. So all we need to do is we need to give the file executable permissions and then move it into our user local bin directory. Okay, and then rebar 3. User local bin rebar 3. Compile. Permission denied. I guess we need to run it with sudo. Command not found. Did we not move it? Oh, we didn't. For some reason, we didn't give it. I thought I gave it. Oh, jeez. It has to be this. Rebar dependency could not be loaded for some reason. No such file. ASN1.f. Okay. This is not great. Okay. URLC make this doesn't work either. I wonder if there's an example of this, if we can get this brute forcing program online. Erlang cookie brute force script. Okay, so we've got another GitHub over here. Let's take a look at this GitHub project. Okay, so it offers arbitrary. This distribution offers arbitrary code execution and its access shell has been protected. Okay. Okay, so let's see, move brute force, Python. Let's see if there's another more straightforward GitHub project. Okay. This Python module and example script should help you get started in evaluating pen testing Erlang distributed protocol nodes. All right, let's take a look. So this is ERL Popper. It's a Python module and example script. Helps with evaluating pen testing Erlang distribution protocol. This is not an official thing, okay, not very fast. It does not interact with Erlang. Okay. This doesn't help because I'm interacting with Erlang port mapper daemon. Okay. Maybe we should be more specific. Let's search for Erlang port mapper daemon, cookie, brute force, script. So this was the where I got the original brute forcer program, but it wasn't a script. It was an Erlang program. Well, let's take another look at this thing. Okay, so let's see. Move brute forcer to Python. Let's take a look at this script over here. Okay, so let's copy this and let's give it to ChatGPT for some analysis. What does the following script do? The Python script appears to be designed for interacting with an Erlang node and attempting authentication through an authenticate function with this module. Here's a breakdown of what it does. Okay. Variety of utility modules, right? Start an integer, stop an integer. Derive cookie. This function derives a cookie based on the given seed and a specified size. The cookie is a byte array. The resulting cookie is in the form of a sequence of ASCII characters from A to Z. This cookie is presumably used for authentication with an Erlang node. Main script flow, interval handling, execution flow. Okay, so what information do I need to give the script for it to run? To run the script successfully, you need to provide the following information via command line arguments: the Erlang node, so the address of the Erlang node you want to authenticate with, this is required, -- target IP address, the port, this is required, this port. You can provide one of the following to specify the intervals from which the seeds will be derived. I have no idea. Simulation count, the number of simultaneous authentication attempts to perform at once. The batch size, default is 16, you can specify a different value if desired. Optional flags. Okay. So let's just copy this for fun. Actually, I shouldn't have done that. I should have copied the script. So copy the raw file, then go over to backout, and we're going to create this. We're going to call it Erlang brute. Paste in all the code here. So Python Erlang brute, and we have to supply a port 4369 and a target 10.0247. I think this is what we're looking for. Okay. Let's try running the script. No. ERLDP. Oh, I need to import a module. Okay, let's take a look at the okay. Import async IO. So do I have all these libraries? I might have to install I might have to install all these libraries. Okay. Of the Python modules required, which are non-standard. The following Python modules are non-standard. Okay, async IO, sys. Oh, these are standard. These are standard. Non-standard libraries are ERLDP. So we can probably install it via package managers. HackSmarter just rated the channel with 26 viewers. Thank you very much, HackSmarter, for giving me a raid. Welcome raiders. And may I ask what you guys were doing in your stream? We've got some people following. Leon VQZ has just followed. Thank you very much. Black Ash has just followed. Thank you very much. What else do we have? All right. So thank you very much, everybody, for the raid. And we're just working on a box over here. Thank you very much for following Bob blah 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 Lud. Thank you very much for following XCESV4C. I'm not sure how to pronounce that, but thank you very much for the follow. And let's give a Hack the Planet. Thank you very much for following Cyber Research. Excessive Ford. Okay. Excessive Force. Oh, interesting. Excessive Force. Okay. Is it night there? Yeah, it's 7:17 over here. We're on the west coast of North America. We're just figuring out a brute force script.
Hack the planet! Hack the planet! Shut up again!
We're just figuring out a brute force script for the for an Erlang service. I've never interacted with this before, so I'm just reading up and doing some research on what this thing does. Vasilis PC. Thank you very much for the follow on Twitch. Thank you very much. It is 9 a.m. here in Nepal. Hello Nepal, how are you doing? West Coast, Best Coast? Sometimes. Hack smarter, not harder. Thank you very much. What were you all looking at? Oh, you can give it some Azure Labs for pen testing. All right. So everybody, my name's the Shy Hat. I run a program called HackerFrogs. It's all about introducing new people to cybersecurity and introducing cybersecurity in a very beginner-friendly way. So we're just doing a little bit of hacking against this CTF exercise. It's called First, and it's located over at the VulNyx website over here. This is a service where you can download vulnerable virtual machines and hack against them. These boxes are very rarely beginner friendly. I found myself stuck many times doing these exercises. But if you'd like to join in, you can download the virtual machines from the website and start hacking against them. It's a free service. There is no option to pay. I think they have a donation page, but that's about it. And we're hacking against machine number 54, I think it is. Machine number 58 on the website, which is called First. So we're dealing with Erlang. Does anybody here have experience with Erlang, Port Mapper Daemon? Thank you very much for following Dick Looter. Dick Looter. I don't know if I should be saying that username out loud, but thank you very much for following. So VM number 1 is easy. That's not necessarily the case. So the VMs are just this is the release order. The machines are all color coded. The easiest machines are this light blue color, and then green, and then yellow, and then red. So I've only ever done up until the green level over here, the easy level machine. But it's been very. Thank you very much for following. Redden the Threat. Redon the Threat. Thank you very much for following. Let's do a couple more redeems over here. This is my favorite bird. These are called Stellar Jays. And if you want to take a look at Stellar Jays, I have a bird feeder that has a little camera over here, and the Stellar Jays come and they feed from the bird feeder every day. And this Stellar Jay has a broken leg. You can notice over here he's limping. So thank you very much for following Klondike 7000.
Yay, Pico CTF, CMU love here. Go for it on VulNyx and have fun. Thank you very much. And just let me see if where did the Stellar Jays come back? They come back over here, yeah. Look at that guy, he's gobbling up all those peanuts. I enjoy these guys a little bit too much. They're a lot of fun. Anyways, let's get back to hacking. Okay, so what we're trying to do is we're trying to get a brute forcer script to work. We've got Erlang, and apparently Erlang is a service that requires a cookie to log in. And in order to determine, we can actually brute force the value of this cookie with the script. But this script over here, if anybody wants to take a look at the script, it's located over here. So I've got the link in the chat. So we need to install some Python libraries, some Python modules, in order to get the script to work. So erldp. So pip install erldp like this. I can't find that. Okay, so how do you install this? erldp. erldp. You would use pip. Well, I don't know where. How do we install the erldp module with pip? That's a good question. So pip install erldp. That didn't work. Let's try one more time. Pip install erldp. No. Cannot find a version that satisfies the requirement. So is this a Python 3 script or is it a Python 2 script? If it's a Python 2 script, then that changes a lot of stuff. So we can probably tell if this is a Python 3 or a Python 2 script by taking a look at the There's no print. I don't see any. Okay, so the print syntax over here, this is Python 3 syntax. But how do we install that? Let's see. Klondike 7000 says, love the ornithology bird video share. Cornell Labs Merlin Bird app has been the best bridge of technology with research. Instead of physically tagging birds, lets everybody's smartphones collect us info from all around the world. Really awesome. Yeah, I use the Merlin Bird app myself. I usually use it for sound ID. So I just turn on the sound ID and then listen to the birds and see what birds are around. It's really cool. But let's see, how do we install this darn library? Ajuda Manning Dev, can you try this one? Saw C script as well. Yeah, we were actually looking at that previously, and I think it's the. Let me take a look at the link. Okay, so let me paste this in. Okay, so this is brute force based cookie completion tool. This is this C? I mean, I'm actually not very familiar with C, but I guess this is C. I was taking a look at the. I think I was taking a look at the Python brute forcer over here. Oh, okay. Wait. I think I need to download. I think I need to download this. Yeah, right. So I need to download this file. Okay. Ajuta Mangdev. Yeah, I see it. I think I'm gonna try using the Python one, this Python brute forcer, and if the Python brute forcer doesn't work, I'll try. If the Python brute forcer doesn't work, I'll try the one with C. I'm more familiar with Python, so if there's something goes wrong, I can do some debugging. So what is the name of the file? The name of the file is earldp.py. Okay, so let's try running the script again. One of the arguments, internal distribution seed full space sim, is required. Okay, so let's try sim. '16. Go back here. Make sure that the appropriate files such as intervals.json exist in the right intervals.json. Intervals.json. Hold on. Let's go back. You know what I should have done? I should have git cloned this entire repository. So let me let's git clone the entire repository. Okay, that's probably the better way to do it. So git clone the entire repository here. Okay, so we've got all the files in the Git repository here. And let's... What is this called? This one is called... This file is called brute force eardp.py. Brute force earldp.py. We have to use Python with that. Okay. Target and port. So we need the target, we need the port. Target is this over here. Port is 4369. Okay, one of the arguments, interval distribution, seed full space sim, is required. Okay, so what did ChatGPT tell us about that script? The number of simultaneous authentication attempts to perform at once, the batch size, default is 16. So let's set it to the default, which is 16. We need another argument, interval distribution or seed full space. You can provide one of the following to specify the intervals from which the seeds will be derived. It wants interval argument 2. Okay. Okay. Specify individual intervals as comma separated values. The interval format is start, stop, prob, where start is the starting number, stop is the ending number, and prob is the probable selection of that interval. You can provide this argument multiple times to specify multiple intervals. Distribution, a path to a JSON file that contains an array of intervals with their start, stop, and probability values. The intervals will be read from the file and used for generating seeds. Seed full space. This flag tells the script to use a predefined interval spanning the full seed space 0 to... okay. So if we don't know what we want to target, we can use this. You do not need to provide any further arguments if you use this option. Okay. So this is some real brute force stuff right here. And let's try running 32 simultaneous. Seed full space not allowed with the argument sim. Okay. Klondike 7000 says, yes, nice, through the seed full space, right. Unrecognized target. Why is this unrecognized? Let me take a look. Target port. Okay. So I guess this is positioning. So I just need to copy this. We put seed full space here, and then we do target, and then we do port. Okay. More errors, okay. Okay, the IP address is correct. The IP address is correct. The port, I need to check the port one more time. So let's do a quick Nmap scan and find out what port that is. It is 4369. Okay, that's confirmed. $43.69. Okay, so what is going on with this error here? Namespace, interval none, distribution none, full seed space, target, port. Line 90. What is going on with this error? We ran the script and received this error. So the error you're seeing is related to the async IO stream read operation in the file. Specifically, it happens when the receive dframe function tries to read 2 bytes, but instead it gets 0 bytes. This incomplete read error indicates that the connection may have been closed unexpectedly, or there is a problem with communication between your script and the target Erlang node. Okay, so maybe it's not working because the Erlang node is not functioning. Okay. So this has been a problem with this box this entire time. We don't. Okay. So the problem is Nmap we've been scanning this this target, and it doesn't give us very much information. Every time we try to get some information from the service, it doesn't give us any reply. So we scan it, we try connecting to it, we can't get any information out of it. The only thing we know that the service is open and that it exists. So ClownX7000 says, try with the IP in the port defined again. Yeah, I'm with you on EST. Oh, I'm not on EST. I'm on PST. I'm on the West Coast. But if you're on the East Coast, then you are still a cool dude. I have nothing against people who are on the East Coast. But yeah, try with the IP and port defined again. The problem is I haven't. Okay, let me I haven't been able to connect to the machine. So we can netcat, and we can try to send something to the system. But anything we send to the system is just going to cause it to close. So there's no progress being made over here, unfortunately. I thought that I might be able to communicate with it if I was able to brute force the cookie, but unfortunately, when we try to brute force the cookie with the script, it doesn't send us. It looks like it's not sending us any data. So, incomplete read error, 0 bytes read on the total of expected 2 bytes, right? Let's see. So Klondike is sending a netcat command. Sure, I can try that out. So over here, we send this. Huh, what is this? It is open. It doesn't send us any data. If we connect to the port and we send anything to it, it just closes the connection. We've tried a bunch of different techniques for enumerating the service, but we weren't able to get it to send any sort of message. I was thinking that if we were able to get the value of the cookie by brute forcing it, then we would be able to get somewhere on this on testing the system. But nothing I've sent to the system has given us any response. So normally when we run this nmap script, it should give us some information about nodes over here. But the only information we got was that the port was 4369. So we also tried using the Erlang terminal over here to interact with the host, but that didn't work either. So according to Hack Tricks over here, we could give this kind of command right over here, and then we supply an IP address. That nothing comes back. This is our attacking machine. Nothing comes back. So the only other thing that we found on the system is this text list. This text file that says task list. It says go shopping, make coffee, update Raspberry, go hairdresser, request salary increase, clean my room. Maybe there's something to do with Raspberry Pis and Erlang that could be used as an exploit. So if we look up something like Raspberry Pi Erlang vulnerability. 100% love that task list. Yup. Oh, okay. Possible Erlang vulnerability. There is one more problem with Erlang. If no cookie is found at the service startup, a cookie is auto-generated. Is that... Dirty pipe? I don't think this is what we're looking for. Erlang on Raspberry Pi. That doesn't say anything about vulnerabilities. Okay. A vulnerability has been discovered and corrected. What? Okay. I mean, I don't know if this is relevant or not. Okay, using a throwaway because my post on my real Reddit would identify systems vulnerable. Okay. Erlang opens a port mapper on port 4369. Unfortunately, the Erlang runtime environment runs with system privileges on most Windows systems. Okay. If no cookie is found at service startup, a cookie is auto-generated. Most systems use such auto-generated cookies. Unfortunately, the randomness of the cookie is a bit limited. It uses the time between service start and call the function to generate the cookie as a factor. You can find some research. So this is the GitHub repository that we're looking at. Shows that the cookie is generated by a seed. It can be narrowed down to a narrow numeric range. This interval is individual for each hardware platform. Okay. So it's basically saying that if you're able to brute force the cookies, then you can get remote code execution on the system. But man, I can't get the brute force to go through. All right, so I should probably get going soon because it's getting kind of late over here, and I need to get some dinner. But let's see if anybody else in the InfoSec community is streaming right now. No, they are not. All right, so let's see. Let me take a look at my Twitch. Let me take a look at my Twitch list and see if there's any good streamers streaming right now. Okay, let's see. Oh, the science channel is on. Yeah. These streamers do science. They do science. They talk about ants and stuff. they're great. But anyways, when you arrive on their channel, if you could give this raid message, it's hip hop hack with the OS frog. I would really appreciate that if you could supply that as the raid message. Before we leave, let's do one last hack the planet.
Hack the planet! Hack the planet! Shut up and get it!
Okay, we're ready. Let's raid the science channel. Raid science streams. Hope I have this spelled right. Okay. Everybody, we'll be back on Friday, and we're going to be doing some web app hacking, and we're going to be doing web app hacking, and we're going to be talking about OS command injection and stuff. It's going to be a ton of fun, and I hope to see you. Have a great rest of your week, and we'll see you next time.
Turkey